Ladies and gentlemen, I'm delighted to introduce you our 6th International Conference on Management of Manufacturing Systems. The conference provides the result of fruitful cooperation among the European Alliance for Innovation, Faculty of Manufacturing Technologies with the seat in Prešov of Technical University of Košice, and the Department of Information and Communication Traffic, Faculty of Transport and Traffic Sciences, University of Zagreb in Croatia. Our ambition is to establish channels of communication and disseminate knowledge among professionals working in manufacturing and related institutions. We cordially invite experts, researchers, academicians and practitioners in a relevant field to share their expertise from the field of management of manufacturing systems. Let me introduce you our organizing committee. The general chairs are Professor Dragan Peraković from University of Zagreb, Faculty of Transport and Traffic Science in Croatia, and Associate Professor Lucia Knapčíková from Technical University of Košice from Faculty of Manufacturing Technologies from the Slovakia. Our co-chairs are Marko Periša, Michal Balog and Anna Maria Behúnová. Let me introduce you our keynote speakers. Dr. Honoris Causa Professor Junaj Sinaj from Technical University of Košice with his keynote speech Hydrogen, the Energy Medium of the Future, National Hydrogen Strategy of the Slovak Republic, and the keynote speech from Dr. Bri Gupta with title his keynote speech Cybersecurity and Critical Infrastructure Protection, Opportunities and Future Perspective. In light of the latest knowledge and findings from scientific projects, the authors present actually trends in the given field. This issue not only defines state-of-the-art in the area, but in additionally explores related topics for future research. The submitted papers on 6th International Conference on Management of Manufacturing Systems 42, accepted papers 19, and we have 2 keynote speakers. The worldwide participants from Bosnia and Herzegovina, from Croatia, from Cyprus, Czech Republic, Ecuador, Serbia, Slovak Republic, United States of America, and United Kingdom. Big thanks to all our authors and co-authors and reviewers for their significant contributions during the specific worldwide pandemic COVID situation. We appreciate your work very much. Thank you so much, and let me wish you a pleasant day.
Dear ladies and gentlemen, let me welcome you to the Eai Mms 2021, the 6th Eai International Conference on Management of Manufacturing Systems. I am Aleksandra Szczeciejowska, the Eai Conference Manager of MMS. Unfortunately, due to the COVID-19 pandemic, I am not able to meet all of you in person, so I am using this opportunity to address the organizing committee, the keynote speakers, the authors, and the participants on behalf of the European Alliance for Innovation. First of all, I would like to thank all of you for being a part of this conference and for your involvement with EEI. Above all, I would like to express my gratitude to the general chairs, Lucia Knapčíková and Dragan Peraković, for their hard and excellent work throughout the whole process of the conference preparation. During today's event, you can actively participate in 2 ways. Firstly, you can join the Q&A on Slack through a link that you can see below this video. Upon accessing the Eai Mms 2021 Slack workspace, you can enter the channel called Discussion. Secondly, you can vote on individual presentations and leave your fellow researchers feedback on their work through EEI Compass. I would also like to use this message to invite you to join us again soon. I am glad to announce that the next edition of the conference will take place in October in Krynica, Zdrój, Poland. I invite all of you to participate in MMS 2022. Should you be interested in being a part of the technical program committee, please do not hesitate to contact me at my email address below. Similarly, if you are interested in discussing other possible cooperation, organizing a conference or a workshop, please contact me at my email address as well. To sum up, it is our honor to organize this year's edition of MMS Conference. I hope you will have a wonderful time during this event and that you will follow the next edition in 2022. We will keep you posted and the news about this event will be available on the conference website. Now, our community manager Michal will talk more about what EEI does, who we are, and how you can get involved in our various activities. Thank you for your attention and enjoy EEI MMS 2021. I hope to welcome you again next year in Poland.
Hi everyone, my name is Michal Dudic. I'm the community manager at EEI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EEI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EEI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EEI Compass, Community Review, and EEI Index. Firstly, EEI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EEI Compass website, compass.eei.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EEI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EEI Index. EEI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EEI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EEI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work-in-progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Ladies and gentlemen, dear colleagues, first of all, let me thank the conference organizer for the opportunity to present trends in the use of new energy media, and it is hydrogen that has the properties to be used to achieve the goals of a climate-neutral Europe by decarbonizing industrial and transport processes. For this reason, the title of the lecture is chosen in accordance with the above consideration: hydrogen, the energy medium of the future. Hydrogen is one of the strategic tools for achieving the goals defined in the Green Deal for Europe. It can be used in society as a substitute for fossil fuels, e.g. coal, natural gas, methane, as an raw materials for application in the chemical industry, e.g. production of ammonia, methanol, production of plastic, in the petrochemical and metallurgical industry, e.g. processes of oil purification, modification of properties of producing steel, and in the future also as a substitute for used coke. An important sector for the use of hydrogen is transport, especially in the transport of heavy loads by road, rail, water and air. In the future, the use of hydrogen is also expected in the propulsion of passenger cars, especially for longer distance. From the point of view to the use of hydrogen, it is important that the transition from the currently used grey hydrogen to green or blue hydrogen. The criteria for its classification into these groups is the method of electricity production which will be used in the production of hydrogen. In the production of green hydrogen, there must be renewable energy sources, e.g. wind, solar cells, biomass. Blue hydrogen requires the use of energy in the production, in which the share of CO2 in the production of energy for electrolyzer or electricity from natural energy sources is used. The Slovak Republic will subscribe to these two types of hydrogen. Hydrogen as an efficient energy carrier has become a strategic element, the use of which in the industrial practice created the condition for reducing emission through emission-free or low-emission application of various types of technology and product. Hydrogen technology, as well as produce using them, can actively contribute to the acceleration of national economies in the context of sustainable development in line with the Paris Agreement, which aims to achieve a carbon-neutral society by 2050. Achieved partial results of the current use of hydrogen in the European and Slovak economic area, the intensity of scientific research and the application of innovation in its use have created the condition for the development of strategic materials that defines the place of hydrogen technology in the Slovak society. With the elaboration of the national hydrogen strategy with the apt adjective "prepared for the future" and its approval by the government of the Slovak Republic on June 23, 2021, the Slovak Republic became part of the hydrogen community within the European Union. It has joined the major countries that are defined their energy future in line with the conclusion of the Paris Climate Agreement, of which the use of hydrogen is an efficient part. The strategic importance of hydrogen use is defined in the Hydrogen Strategy for a Climate Neutral Europe, approved on 8 July 2020. The Slovak Republic has joined the countries AG Germany, the Netherlands, the Czech Republic, Sweden, France and Italy, which have in the near future will receive their national hydrogen strategies. Through the elaboration and subsequent approval of the national hydrogen strategy, the government of the Slovak Republic primarily pursues the following objects. First, contribute to the decarbonizing of society through the use of green hydrogen produced from renewable energy sources. Blue hydrogen will also be used during the transition period. Second, creating conditions for intensive development of hydrogen technologies in all stages of the hydrogen chain: production, distribution, storage and their use. Third, increasing the competitiveness of the Slovak industry by supporting research and development. 4. Ensure capacity for the production of energy from renewable sources. In addition to domestic sources, prepare conditions for the import of green hydrogen. The authors of the National Hydrogen Strategy in the Slovak Republic divided its context in 5 chapters in order to cover all areas of hydrogen use in the Slovak economy. The structure of the strategy is in line with the context of the strategy of two EU countries, where they are already approved in individual government bodies. Part 1, which contains a preamble to the strategy, its starting points in line with the European Union's climate neutral hydrogen mission. Part B of strategy is devoted to the use of hydrogen. Attention is paid to those industries in the Slovak Republic that form part of its industrial background. It is about use of hydrogen in the chemical industry, changes in the metallurgical industry by reducing the consumption of gray hydrogen and its replaced by green or blue hydrogen. Solution for hydrogen transport, distribution and storage. Use of hydrogen in transport mobility. Part C is devoted to the transformation of Slovak industry into hydrogen economies using green or blue hydrogen. The support of the government in the Slovak Republic for the activities defined in the strategy is specified in Part D. The strategy pays significant attention to research and development tasks and thus to the connection to the training of experts for all stages and the hydrogen chain. Part E proposes producers for funding research activities and defines the establishment of the Hydrogen Technology Research Center in Košice. The most way of using hydrogen in the propulsion systems of mobile vehicles in the application of fuel cells, which create new opportunity in the market. logistic system has been created for the use of hydrogen in transport, which includes areas of hydrogen production and its use for various types of mobility. Attention is paid to the production of hydrogen from renewable energy sources through the infrastructure for refueling hydrogen to its use in individual mobile devices. In this logistical structure, I am also considering the participation of the Center of Hydrogen Technology in Košice in the research of new possibility of hydrogen application in the Mediterranean. Established of the Hydrogen Technology Research Center in Košice, CVVT, it will operate as an open research institution with a nationwide scope. CVVT's partners will be research institutions abroad as well as from industrial practice. The center will be a coordinated and advisory workplace in the establishment of new study programs with a focus on the use of hydrogen. The signing of the memorandum on the establishment of CVVT in Košice took place on 5th September 2020 with the participation, in the photo from the left side, of the President of the Slovak Academy of Sciences, Pavol Šajgalík, Vice President of the European Commission, Maroš Šefčovič, Hydrogen Technology Coordinator in the Slovakia, Juraj Sinaj, Rector of the Technical University in Košice, Stanislav Kmeď, Rector of the Pavol Jozef Šafarik University in Košice, Pavol Sovák, and Deputy Prime Minister and Minister for Economy of the Slovak Republic, Richard Sulik. Conclusion: EU countries and Slovakia have committed themselves to reducing greenhouse gas emission by 55% by 2030 compared to 1990 and to decarbonizing society by 2015. One of the solutions is the use of hydrogen as an energy carrier in its entire value chain, from its production through transport, distribution, storage, use to production in end technologies, products and components for the hydrogen economy. The implementation of the National Hydrogen Strategy prepared for the future into practice through an action plan will create the condition for the decarbonizing of the economy and energy, industrial processes, transport and mobility. With the adoption of the National Hydrogen Strategy, the Slovak Republic joined the countries of the European Union, which created a government framework to meet the goals of achieving a climate-neutral society by 2050. In the last slide, I would like to mention the pleasure of the Deputy Prime Minister of the Slovak Republic, Richard Sulik, and the Hydrogen Technology Coordinator in Slovakia, Juraj Sinaj, over the construction of the first hydrogen-powered bus in the Slovak automobile industry, which includes a metal hydride hydrogen tanks developed at the Faculty of Mechanical Engineering at Technical University in Košice. Thank you for your attention, and we believe that the culture of hydrogen use will become part of the culture of the countries of the European Union and thus the Slovak Republic.
Good morning, good afternoon, and good evening. Different participants from different parts of the world. This is Brij Gupta. So today I'm going to present my keynote talk on cybersecurity and critical infrastructure protection, opportunity and future perspectives. First, I would like to congratulate organizers of Eai Mms 2021 for organizing this wonderful conference and inviting me to deliver this important keynote talk. So during this talk, I will cover introduction, statistics and incidents, need for cybersecurity, emerging cybersecurity challenges, major cybersecurity attacks on critical infrastructure and protection mechanisms, open issues and challenges, and then finally I'll conclude my talk and discuss some future research directions. So as we know that Internet has become increasingly important to current society. It is changing our way of communication, business mode, or we can say everyday life. As today, most of the devices are connected to Internet service disruption is less and less tolerable. So today, devices more than people are connected to Internet, and Internet is used for many services, or it is used by many citizens, businesses, and government. Security problems are major obstacle in further development of Internet. So in some, we can say like Internet is making our life easier, smarter, but dangerous. And cyberspace is considered as fifth battlefield after land, sea, water, and space. Therefore, securing cyberspace of any country has become now as critical as securing the geographical borders. And facilitating world-class research and innovation in this domain can play a significant role to secure cyberspace. This is exponential graph where you can see how internet connected device number is increasing. So it's represented by internet domain host count. The number of devices connected to internet is increased exponentially from 1993. This is like internet user as per their uses on mobile and social media. So if you can see like active internet users, active mobile internet users, active social media internet users, all this information is given here and how they are increasing. Here are the top 20 countries with the highest number of internet users. So you can see like India and China top the table because of their high population. This is like most sensitive information which need to be protected from cyber attack. So customer record, intellectual property, credit or debit card information, financial information, etc. are on the top of the table. This is distribution of different type of attack. So malware attacks are mostly performed by the attacker to exploit the various information in critical infrastructures and inside the criminal data breaching, SQL injection, and so on. This is attack distribution on cloud applications. So you can see like e-commerce websites are mostly targeted, then online gaming sites, DNS services, financial services, and so on, because the businesses of e-commerce or online game sites are up when they are up and they are usable or accessible from the different users. This is attack distribution based on the different protocols. So you can see like sync flooding attacks are mostly targeted by the attacker, than HTTP, GET, UDP, and other. Attack distribution based on the application protocol. So it is like HTTP based attacks are mostly targeted because of internet services are, they use HTTP protocol for various services. When we talk about attack on mobile devices, then you can see like Android-based mobile devices are mostly targeted, than iPhone, iPad, etc. with the different attacks. When we talk about attack distribution of cyber attack during COVID-19 pandemic, so phishing and fraud are mostly done by the cyber attackers, than malware or ransomware attack, malicious domain, and so on. This is like cyber attacks for consumer data breaches in top 10 sectors when we talk about critical infrastructure. So healthcare system are mostly targeted, and then retail, education, government and public sector, and so on. And this is like cyber attacks in consumer electronics and critical infrastructure. So there are different types of attacks which are mostly performed by attacker, as we discussed earlier. So malware attack, ransomware attack, phishing attacks, SQL injection attack. These are mostly targeted by the attacker and so on. So we'll discuss all these attacks one by one later on in brief, and then we will cover some different solutions. So here you can see like CS graph. So you can see like cyber security. If we increase the cyber security, cyber crime decreases. So it's two sides of the same coin. So we need to work on more on the cyber security so that we can reduce the cyber crime in the critical infrastructure. Now comes to the motivation to violate the security. Why attacker perform these attacks? So there can be different reasons. Some of the reasons we have mentioned here, like financial or ransom payment, competition, revenge, ego, curiosity, fun and attention, political and ideological reasons. So these are some of the reasons because like without any particular reasons, it is difficult to perform a successful cyber attack. Then why information and cybersecurity needed? Because cyber attacker, intruder, and terrorists got smarter. Every aspect of our life is connected to the internet, and attacker can attack from anywhere in any form. So one attack can cause financial losses, information breaches, unavailability of resources affecting the confidence in the system. So it is not actually necessary like attacker need to be connected in the same network of the victim, or it should be directly or indirectly connected. So if anybody is connected to internet, then attack traffic can be generated from any part of the world. Some of the major attacks are like distributed denial of service attacks, phishing attacks, botnet attack, man-in-middle attack, and so on. So we'll discuss some of these attacks and different solutions. Then why cybersecurity, information in cybersecurity needed, as we have already discussed. So another important point in this regard is the current scenario of cyber attack across the globe. So especially when we talk about critical information infrastructure, it's a need of our to take immediate initiative to protect our CII, because critical information infrastructures are backbone of any country, and it can create huge losses for that country or state if critical information infrastructures are damaged or it is exploited by the attacker. Like, for example, failure of different power grids, mobile systems, transportation system, etc. So some of the critical infrastructures are like transportation system, banking system, smart grid system, protection of military services system, and so on. And StackNet, a computer malware that target industrial sites in Iran, is an example of how the cyber attacks are performing on the critical infrastructure of any country and how much damage it can done. And there are many other attacks unofficially done by different group of cyber attackers on different parts of the world. These are some of the important research activities which can be carried out in this domain. So research in the area of critical infrastructure, information infrastructure, security, cyber crime, cyber systems. So this is actually important, like how we can contribute to ensure the security of critical information infrastructure. Then development of security solution in the form of hardware and software product to ensure the CIA security, because it's a need of ours, and every country requires this kind of protection. Identification of unexplored critical information infrastructure. So some of the critical infrastructure even not known to the. So it is important to explore such critical infrastructure, and then protection mechanism can be developed. Design and development of testbed for simulation of advanced malware analysis and reverse engineering. This is another important point, actually. And development of reliability of and security standard testing. So these are some of the points that like somebody can explore to do the research in this domain. Then this is a slide which we can show the element of cybersecurity. So cybersecurity composed of different security aspect like application security, information security, network security, disaster recovery, operational security, and so on. And this is a complete picture of cybersecurity. So you can see that cybersecurity, when we talk about the cybersecurity, we need to protect the architecture, identity and access, defense. So these are the three different components. And when we talk about the architecture, it composed of software, hardware, network, And like we need to ensure the security of OS applications information, as well as when we talk about the hardware, we need to ensure the security when the information is in the computational, it is stored or it is given as input or mobile, and so on. When we talk about the defense, it can be like AAA model, authorization, authentication, and accountability. So authorization can be done by ID-based, role-based, or rule-based, and so on. There are many other authorization mechanisms also. When we talk about authentication, it can be password or biometric, callback, certificate, etc. And when we talk about accountability, so accountability is important because we need to know what is going on into the system. It is like what is ingress traffic, outgress traffic, and so on. So access log, error logs, and other logs can be evaluated, checked to analyze actually what is wrong in the system and whether the incoming traffic is suspicious, and accordingly the protection measures can be made. This is when we talk about the defense, it can be software-based, hardware-based analytics. So there are many software, hardware-based defense mechanisms are available either in the form of antivirus, anti-malwares, firewalls, etc. So these are some of the emerging cybersecurity challenges. You can see like digital data security. I mean, this is important area of research. So it is like how we need to look about the cybersecurity challenges and how we should contribute in this domain. Then digital payment security, because we mostly do lots of payment. So again, it's important to secure that. Security against ransomware attack, because it is very serious and so many attacks increases over the time of the attacker, which are in the category of ransomware. Smart city security. IoT security is again because IoT gadgets using IoTs are increasing over the time. Cloud computing security. Mobile security is again important because we have very important informations in the mobile, even important as well as private information. So security is important. Critical information infrastructure protection is again very important and challenging because, as I mentioned earlier, it is a backbone of any country and protection is very much needed. Then healthcare security, banking security, cyber litigation, cyber insurance. It is again actually very important because, like in our daily life, we do the insurance like car insurance, vehicle insurance, health insurance, life insurance. So similarly, some of the organization, small scale organization, which is not having some defense mechanism or protection to protect their organization, they can hire some agency or they can take some cyber insurance by paying some premium and then divert the attack traffic, or somebody else can handle the incoming traffic to protect that small scale organization. This is again very interesting area of research, and it is also useful to protect the critical infrastructures. When we talk about the defense mechanisms, so there are various internal defense mechanisms, and which can be further, specialized, and some appropriate action can be taken against the attack. So preventive measures can be taken, detection techniques can be used, response actions can be taken once the attack is detected. Network forensics can be, it is like a reactive mechanism. So network forensics approaches can be developed so that future attack can be handled. Traceback mechanisms can be used to find out the source of attacker, and then appropriate action can be taken from the source from where attack traffic is originated. Firewall filtering can be used so that attack traffic should not be entering into the system. Honeypots can be used to make it like protect some actual server and attract the attacker to perform attacks so that they can capture the attack traffic, their signature, the pattern in the incoming traffic, and then appropriate security solutions can be developed to handle such attacks in future. And trusted computing platform is again one of the important area because hardware security is very important, and we need to ensure the security at the hardware level. Then I will discuss like how the DDoS attack is very serious against critical infrastructure and some of the defense mechanisms which apply to deal with this attack. So as the name suggests, distributed denial of service attack uses large number of zombie machines to launch launch a coordinated DDoS attack against the target. So it is like basically a check on availability of information. So it completely shut down some of the major websites like Yahoo, CNN, Amazon, eBay in Feb 2000. And at the time, it came into the attention. And then after, people start tracking and providing solution to handle such attacks. So it is like modus operandi. Attacker first scan internet to find out some unsecure machine and then install the attack program secretly on these machines, and these machines are called zombie machines. Then some control master machines are selected to coordinate between the attacker and the zombie machines and to even hide the attacker's identity. And then information like regarding when attack will be performed, what should be the target, what attack type, how much impactful it should be. And such information is passed to the control master, which later on coordinate with the zombie machine, and then attack traffic is sent to the target machine, and services for the legitimate users are denied. So this is actually like how it is performed. When we talk about the classification of defense mechanism against DDoS attack, so it can be before attack, during attack, or after attack, and so on. And when we talk about the mechanism, like where we are applying actually defense mechanism, so it can be near to the source network, it can be in the destination network, it can be at the intermediate router, or a hybrid mechanism. So there are different ways, actually, different places like defense mechanisms can be deployed, or solutions can be deployed. So these are some of the research we have developed to protect against DDoS attack. So I'll give you a brief idea, and then if you have any queries or something, we can discuss later on, because it is not possible to give the detailed overview of each of the solutions. So we have developed a flow volume-based approach for DDoS detection, defensive solutions against fraudulent resource consumption attacks. It is again very important attack against the resources in the clouds, FRC attack, defense mechanisms against DDoS attack based on the entropy in SDN cloud, detection and protection against flash crowd event, economic incentive-based solution against DDoS attack, PBN and economic incentive-based defense mechanism against DDoS attack, and so on. So like, what is the idea actually in general, and in the solutions, and how we have developed specific solutions? So when we talk about designing a solution to handle DDoS attacks, so it's important to collect the traffic, then pre-process the incoming traffic, and then calculate some statistical or other evaluation parameter, then calculate the prediction error, apply the threshold, and raise the alarm for malicious packets. So this is like architecture of FBB approach, flow volume-based approach, where incoming flow and volume are measured with the normal system profile we have developed, and then as per the threshold, the attack alarm is raised and appropriate measures is taken. This is like detection model, like how the detection is made, or how the alarm is raised, like system have some suspicious traffic. This is supporting algorithm. So I'm like how we have designed this algorithm. This is data sets used. So attack-free scenarios taken from DARPA intrusion detection evaluation data set from MIT, and high rate and low rate DDoS attack scenario is taken from the data DDoS attack data set. This is like simulation condition when there is no attack. This is the packet per second rate. It is increased when we talk about the high rate attack. And this is like temporal variation of volume metric or flow metric when we perform like low rate attack or high rate attack. This is impact on good put. Good put is like when we talk about the legitimate traffic reaching to the victim at or the target server successfully. So when attack strength increases, the good put decreases. This is impact on normal packet survival ratio. Again, the attack impact increases then. So this is just a sample scenarios. Attack impact can be very high these days. This is detection of DDoS attacks. So how the detection tolerance factor is play an important role in detection and reducing the false alarm rate. This is ROC curves, which can be area under curve between detection and false positive rates. This is our defensive solution against fraudulent resource consumption attacks. So it is like cloud has important characteristics of like pay-as-you-go pricing model. So it is basically like through the cloud's pay-as-you-go pricing model, attacker usually target the financial viability of the cloud customer by performing fraudulent computation. So they run some of the process in the background and just to increase the payment and for the customer. So this attack is slowly performed, and it is capable to affect the long-term availability of services hosted on the public cloud. So this is like how this solution is having three important components like detection module, network flow analysis module, FRC attack mitigation module. So this is a like a kind of complete solution. So it is like how the DDoS attack and FRC attack are different. So DDoS is mostly the disruptive attack, it's disrupt the services, while FRC is a low rate attack, so it challenges the financial sustainability of the victim. Attack duration is small in the DDoS attack because they try to have high impact and high rate attack. When we talk about the FRC attack, it is large attack duration because they slowly degrade the performance. And suitable detection mechanism is proactive when we talk about DDoS attack, and it is reactive when we talk about the FRC attack. This is supporting algorithm. This is proposed approach. This is like how FRC attack mitigation process work. And this is another solution like defense mechanism against DDoS attack based on the entropy SDN cloud. So as you can see, like incoming packets flows are checked with some thresholds. So three important thresholds are used in this particular solution. So current flows, and flow threshold, then entropy threshold, and the count value threshold. So these are some of the threshold, and entropy is major parameter used in this particular approach because it's a measure of randomness and how the incoming traffic is distributed or concentrated. So different data plane, control plane, and application planes are having different functionality, and accordingly the appropriate measures are taken whether the incoming traffic need to be transferred to the victim or it need to be routed. This is supporting algorithm. This is like how detection and protection against flash crowd events is done. So as you know that flash crowd is very popular again. Actually, it is not actually a DDoS attack, but the behavior of impact is similar because it is again reduce the quality of services, or what I can say, disrupt the services because the legitimate user are more and the incoming traffic generated is more than the server can handle. So how excuse me, incoming traffic it checked whether it is having the flash cloud or not. So this is like detection module as well as the neutralization module we have used in this particular solution. Then cyber insurance and DDoS attack, as we have already discussed, like it is very difficult actually sometimes to detect attacks. So the best way is to transfer the risk to some of the billing third party. So cyber insurance is play important role because internet is in non-cooperative environment as well as without financial gain. Actually, people are not willing to support or extend the cooperation. So it's always good to transfer the risk to the billing third party on some payment basis. So these are the limitation of technological solutions and economic incentive solutions like deployment issue, lack of completeness, lack of protection against damage to the legitimate traffic, complexity of the solution, and so on. Similarly, when we talk about the economic incentive-based solutions, it is having high cost, dependency on other, uncertainty and lack of even data and so on. So it is important like to have a hybrid solution so that we can get the best benefit of technological solution and at the same time economical solutions. So why economic incentive-based solutions are important? Because the parties that suffer most are not in the best position to defend against DDoS attacks. So in place of completely shut down and lost millions of dollars, it's better ways to protect economic incentives to other and getting their resources to handle the DDoS attack. So it's always good actually to provide some economic incentive to other billing third parties and get their resources to handle the incoming traffic. So lack of social or economic incentive is the root cause that no distributed defense system can be deployed to handle DDoS attack. Because we know that it's important to give the incentive to others to get their support. And this is like, again, technological solution against DDoS attack, like effective pricing scheme that can maintain desired quality of service and so on. So this is like how our dynamic resource ownership and economic incentive-based solutions work. So it is like a risk transfer-based DDoS attack defensive framework. It incorporates the benefit of both, technological and economic-based solutions. So you can say there are three important communicating entities in this particular solution, like broker network, control networks, front-end brokers. So you know that the control brokers are making the decisions actually, because they are connected to the network where the victim resides. So they make the decision based on the incoming traffic level, and then accordingly the front-end broker make the appropriate decisions. And the broker network is where the trading of the resources available can be done. So it is having a directory manager, which is like a yellow page directory, and information about the billing parties who want to share their resources to handle incoming traffic is maintained in that particular directory manager. And when we talk about the traffic load level, it can be normal level, suspicious level, or attack level. These are different communicating entities and their functionality in this particular solution, like e-cash, attention resources, online payment systems, contract generators, service delivery mechanisms, and so on. So how they are interacting and how they are providing this economic solution. This is supporting algorithm for the verification, and this is another framework we have developed, which is based on the policy-based network management for risk transfer to mitigate DDoS attack. So it is again very important and solution, economic-based intensive solution. So these are some of the communicating entities in this particular framework. This is like how the sending rights can be obtained. And this is auction-based incentivized solution against DDoS attack. Here we have used BCG based auction mechanism to mitigate DDoS attack. And this is like multi-attribute auction-based solution against DDoS attack. So here different attributes are taken in resource directory, auction agent, price predictor. So there are several components they are used to make the decision about the resource auction, and then appropriate measures are taken for dealing with DDoS attack. It is like how the communication is done in this process and how the step transition diagram is done, how the auction is performed, and so on. Now we will come to like other research activities we are doing in this critical infrastructure protection. So we are in the process of developing a center of excellence for cybersecurity and critical infrastructure protection. So it is important because the mission is to world-class center for developing advanced cyber defense technologies for national security and incubation. And it is to develop technologies and protect for critical information infrastructure protection, because it's important actually. We need to ensure the security of CII of any country, as well as to incubate people for developing different solutions and so on. So in this, we cover four important dimensions like national security, big data analytics, because it's important, lots of data is generating, and then it is again important to secure that, then secure interstate computing systems and critical information infrastructure protection. So these are different things we will cover in this, and how the cyber range can be developed. And there are different international partners from universities and industry, and also there are different end users and so on. So the goal and deliverables of this center is like to creation of world-class cyber range to carry out research work in the area of critical information infrastructure security, cyber crime, cyber systems, incubate at least 15 startups working in this domain specified, making sure that at least 60% of the incubated startup reach angel funding, and so on. MOU and collaboration with intelligent organization in subject matter expert and national security, providing intellectual capital, technology-related expertise, collaboration with government organization as a potential test bed, focus on facilitating and the delivering of new technology customer base, which should only consist of intelligent organization of the country, and so on. So these are some of the other activities that can be carried out in this center. And these are some of the open issues and challenges which somebody can explore and develop security solutions in future, like design of cyber insurance policies to protect users from security risk. Because it's important, because we need to make sure actually what is how to design cyber insurance policies, because actual premium is important, like how we can set the premium of the policies that we are making, so that it can be win-win situation for the smaller scale organization as well as the organization which is providing the security. Characterization of security related data set is one of the important area, because we need to characterize the data set we are developing or we are using, so that we can say it is a benchmark data set and appropriate uses can be made. Novel solution, again, zero-day phishing attacks. So this is again important, because phishing is one of the major reason actually these days, because it steals the user credential as well as some private data. And zero-day attack is something because your signatures are not available in the past. So this is again important. And security of critical information infrastructure protection from various attacks is again very critical, because it's a backbone of any country. Identification of unexplored CII in a country, development of security and reliability test board, and quantum computing to develop advanced cybersecurity solutions. So these are some of the important area or open issues which can be addressed in the future. So finally, I would like to conclude this talk like cybersecurity is a major issue in our day-to-day life. Awareness of this issue should be not only be increased within the technical expertise, but it should be also the major concern of every person who is connected to the internet. People, businesses, or government agencies should deploy defense mechanisms proactively to resist any kind of possible attacks. DDoS attacks are complex and serious problem. It is attack on availability of the resources. It is found that economic incentive-based models are required to deal with DDoS attack, and cyber insurance policies need to be designed to protect against various security risks. And again, the quantum computer is our future aspect, and it need to be used to change the traditional cryptographic solutions and other things, so that attackers should not explore and exploit our existing or classical cryptographic solution using the quantum. So this is some of the important directions I tried to give in this talk. I hope actually you have enjoyed and get some different ideas about how critical infrastructure can be protected and what are the challenges and all. If you have any queries, we can discuss. So thanks. These are some of the supporting algorithms, supporting references, and thanks a lot. So if you have any queries, you can email me or as well as you can ask. Thank you.
Hi everybody, my name is Renato Mauricio Todasawachi, and I presented the paper named Monitoring of an Industrial Process based on Industry 4.0. This is a work made by four authors, Mauricio Javier López Flores, Elvis Román López Flores, Francisco Javier Galora Silva, and me, Renato Todas. This work is important because currently there has been a substantial technological improvement in the industrial control rooms that are responsible for monitoring the manufacturing process. In this sense, this article proposed the development of a monitoring platform through the MQTT communication protocol using accessible equipment and a publication subscription model on WebSockets. The platform is simulated on Factor.io software operated by a programmable logic controller, PLC. Its visualization and monitoring are online through a web page, disponible in a web server. After performance and response tests, it is determined that the communication platform achieves adequate and complete operability. Its applicability is simple, scalability characteristics, and adequate level of messaging quality, security, and special communication in restricted environments. Okay, so we present the introduction about this work. In today's environments of global competition, technological development, and innovation companies, especially in manufacturing, are forced to constantly reconfigure this process. The concept of Industry 4.0, based on a smart manufacturing approach, is part of this transformation, in which manufacturing and information technologies have been integrated to create innovative manufacturing, management, and business systems that optimize manufacturing process, achieve greater flexibility, efficiency, and generate a value proposition for their customers, as well as respond in a timely manner to the needs of their markets. The methodology of this work is by architecture, PLC Factor.io, PLC Raspberry Pi, WebSockets, and QoS and security, or quality of service of this platform. This is the architecture of the proposed system to control manufacturing process. We have Factor.io, Ethernet TCP/IP for communication, and a controller, a programming with Python, and the MQTT client on Raspberry Pi. The server is Mosquito Broker. It's permit to subscribe to posts and send and post messages by WebSockets and show in a web page disponible in a web server allowed in internet. We have MQTT clients, web navigator, and monitoring by a computer of people around in this manufacturing industry. PLC and Factor.io. The industrial process plant consists of two parts. The first, the assembly of a material using conveyor belts and armed with X and Z movement. And the second, a tank with level control for filling and emptying. The physical layout of the plant is simulated in Factor.io software with direct connection to the programmable logic controller, or PLC. We can see factory IO, IP address, protocols IP, and the controller system, PLC Siemens S7-112, and IP address of controller of this system. After we have PLC and Raspberry Pi. The data communication between the programmable logic controller, PLC, and the Raspberry Pi to be used as a client is established by means of the multi-platform programming tool Snap 7, allowing to obtain the data from PLC systems through the Profinet protocol as Profibus Ethernet by Raspberry Pi. We can see this device. After we have the WebSockets, the application and development of the web page is supported by the use of MQTT protocol over WebSockets, which in general allows sending and receiving messages directly from two browsers, client and servers. In addition to being able to operate all the features and functions of the MQTT as usual. We can see the architecture of this communication. We have MQTT Mosquito Broker as a server, el data package MQTT, SPP protocol, and over web sockets by the communication. And we can see all information, all data on the web navigator and by the MQTT client. Okay. QoS and security. The quality of service QoS used in the project to define the guarantee of reception of a specific message was mostly zero, due to the characteristics of the network, such as its reliability level and the improved application logic. In addition, the network processes a reliable communication at most stable connection of the system. We assegurate the quality of service of communication by TCL communication, TCL configuration on the server Mosquito of MQTT, TLS, or HTTPS. We can see the communication. The platform has a smooth of dynamic operation with a perceptive real-time response and admissible characteristic of operability and control. Okay, we can see the general architecture of communication of proposed system to monitoring and industrial process by Industry 4.0. So we have the conclusions. The implemented platform based on the concept of Industry 4.0 allows the complete integration of the development process units and evidence applicable and important approach to the industrial transformation so necessary in our country, Ecuador. Evolution achievement based on the technical knowledge, processes, and using open source device, adaptable, no one above all accessible to the user. MQTT is a relatively easy to implement, lightweight and open messaging protocol that allows communication in restricted environments. It is scalable, bandwidth efficient, enables quality of service, and allows message encryption. This is important to guarantee the privacy of communication of client and server by MQTT broker in the system. The development platform is online, consists of two clients. The process is controlled by a PLC simulate in Factor I/O software and is communication with the browser client through WebSockets. After the test operation, response and network traffic analysis, the proposal presents appropriate characteristics and functionality, robust scalability and security for the users of this system. This is the presentation of the work. Thanks, and see you later, everybody.
Dear sirs and madams, my name is Matouš Machka and I am postgraduate student of the Faculty of Mechanical Engineering of Czech Technical University in Prague. My supervisor is Docent Theodor Beran, who is also a co-author of this paper. The research is related directly to the topic of my dissertation and has been supported financially by the student grant given by the Czech Technical University. I will try to explain briefly basics, thought and contributions of individual chapters in this presentation, which are described in detail in the professional paper. In the introductory part, I give basic information about the main objectives and current state of the research. The current state of the research can be defined in the following items. The authors, in cooperation with the mentor from JETI, Czech company, have designed a cost management and costing methodology intended for products falling into the enterprise mains production activities. The designed methodology works with the product input-output model and traditional cost accounting methods. This methodology has already been verified successfully using the conceptual design of a steel construction. A detailed description of this verification will be explained on the following pages. The main objectives of the research are: create a new cost management model based on the modern cost accounting methods integrated with the product input-output model, design suitable methodologies that would ensure the easy implementation of this model in small and medium-sized industrial enterprises. The following reasons can be given as motivation for implementing the designed methodology in a production plant. The main reason is especially to facilitate the production, inventories and subsequent distribution planning process, and to obtain more precise results about the allocation of cost to individual cost objects. This section will examine a design analysis of the steel construction. At first, we will focus on a design analysis of a steel construction for the purpose of the product input-output model. Steel construction manufacture falls into the enterprise mains production activities. The assembly itself of a steel construction consists of a great number of components and assembly groups, which are characterized by their design and technological similarity. These components and assembly groups must be specified more and their mutual relation must be identified. When this documentation is made, we will get a good basis for setting and correctly the values of the technical coefficients in quadrant 1 of the product input-output model. It is always necessary to bear in mind that the calculated results are fully dependent on the chosen values of the technical coefficients. If the values of these coefficients are chosen wrongly or inaccurately, then also the calculated results will be considerably distorted and unusable practically. However, it is exacting to choose the technical coefficients correctly, and this requires a complicated analysis. Carrying out this analysis is very difficult and almost unfeasible for most small and medium-sized enterprises. That is why it is necessary to design such methodology that would help to break this fundamental barrier and enable small and medium-sized enterprises to use high-quality cost management methods at the same time. While in making the required specification of individual design parts, we must base on technical report, which will be provided by the customer itself in most cases. However, the elaboration of these technical reports delivered externally is of poor quality, and thus it disables to use input-output analysis methods. The problems of an analysis of technical reports are connected especially with the following. Assembly parts are not marked clearly and are recorded illogically in the bill of materials. That is why it is necessary to introduce new marking in the drawing documentation, including the restructuring of design parts to a level meeting the needs of input-output modeling. This page shows the schematic representation of the conceptual design of a steel construction on a specific scale. The concept for the steel construction was created based on commonly produced steel constructions and perfectly matches their design and technological complexity. Bill of material structure based on input-output model requirements. This page shows the design for the suitable structuring of initial data, the source of which is the drawing documentation contained in the technical report. The initial data are understood to be the production drawings of individual components, assembly groups, and the final assemblies of steel construction. We divided this set of the technical drawings into 3 groups as shown in Table 1. This 3-stage system provides a comprehensive overview of the respective production components and assembly groups. However, it is not sufficient for input-output modeling. Therefore, the respective assembly parts will be further divided into 3 class groups. The first 2 class groups are designed for separate production components and semi-finished products, and the third class is designed for assembly groups. With respect to a large amount of assembly parts, we have to further classify these class groups into individual classes that will be denoted with the lower case letters and corresponding indexes. The criteria for the index classification are stated in Table 2. By these criteria, we basically mean conditions for assigning an index to the respective class belonging to the given class group. The classes belonging to the group S and group H have only one index that is assigned based on the design similarity of the respective components, but also based on the same production technology. For classes belonging to the class groups M, we designed 2 indexes. The first index expresses the purpose of the given assembly group in the final assembly, and the second index depends on the quantity of components used for the given assembly group. We will use this division not only for designing the input-output model, but also in managing production operations and calculating phase cost, where the cost objects will represent in index groups. Mathematically, the respective class groups may be expressed in the following relations. This relation expresses the dependency of the assembly groups on basic components made of sheet metal and steel beam profiles. Each assembly group consists of these types of components. After this classification, the production process may begin. These slides focus on the arrangement of the production process within the respective production departments of JETI. A thorough knowledge of the production process will help us better understand the relations between the company's mains and the secondary production operations. Especially with respect to the capacity load of the respective in-house manufacturing units, the production process itself is divided into 4 phases that are depicted in Figure 2. The aim of the technology analysis is to set up the production process to ensure continuous operation between the respective phases without any major interference or conflict that would adversely affect the final cost calculation. A high quality technology analysis contains a description of the activities directly related to the production process. Moreover, it provides a basis for applying the modern cost accounting methods ABMC, activity-based management and costings, which is directly related to the cost incurring operation. JETI has 5 production buildings as is shown in Table 3, production departments where both the main and the secondary production operations take place. Within the internal management, however, we will be working with manufacturing units where the main production operations primarily happen. These manufacturing units have a precisely defined working space and form part of the respective production buildings. The introduction of manufacturing units is essential mainly in terms of managerial accounting, because records of overhead costs are kept in every manufacturing unit, and these overhead costs are important for the final cost calculation. This slide focuses on production operations in the first phase. In this phase, production is prepared of the respective components necessary for assembly groups and the steel construction itself. The individual steps of this phase are described in Table 4, where the index classification of the respective classes formulated in the previous slides is fully implemented. Production operations phase 2. In this phase, the design of the assembly groups consisting of individual components which are represented by class group S and H take place. The production technology is the same for all assembly groups classes. The manufacturing units employed one by one are SE manufacturing units, where the welding of individual assembly parts take place, SD manufacturing units, where the cleaning of weldments individual assembly groups take place, SF manufacturing units, where the final surface finishing of individual assembly groups take place. Production operations phase 3. This phase is devoted to the problems of storage. The finished assembly groups and separate assembly parts are stored in the special SG unit. Production operations phase 4. The final assembly of the construction is dependent on the terms and conditions agreed with the customer. This section will describe an economic analysis of a steel construction, within the first two phases which are most expensive from the economical viewpoint. Production operations phase 1. At first, it is necessary to determine the amount of the direct and overhead costs. The amount of the direct cost can be easily found out directly in the financial accounting, where we can find data about the purchase of semi-product and direct labor costs. The amount of the overhead costs can be obtained from the budget of each manufacturing unit employed. When this information is obtained, we are able to carry out absorption phase costing for individual production steps. The calculation will be made for each class group S and H separately. Based on this calculation, we can calculate the initial cost of individual classes. Production operations phase 2. A procedure similar to that in the second phase will take place here. The calculation will be made for class group M. The direct materials cost component will be eliminated in this phase. Now we have all input data available for starting to calculate using the product input-output model. The product input-output model we enable to use to calculate the cost of individual cost objects. In this case, cost objects are individual classes. When we look at the schematic representation of the input-output model, we can see three colored areas. These colored areas are intended for input data and represent three quadrants of the input-output model. The gray area, quadrant 1, is file with values representing the number of pieces within the classes concerned. We have obtained these values of this basis of the design analysis. The values belonging to the light gray area will be 0, and the values belonging to the dark gray area will be greater than or equal to 0. And this depending on the quantity and type of the components of which the assembly group concerned consists. Choosing values in this quadrant is absolutely essential for the accuracy of the final calculation. It is possible to come to conclusion on the basis of a high-quality design analysis carried out that the setting of these values correspond with the reality. We can easily calculate such coefficient using these values that will be accurate enough. The blue area, quadrant 2, correspond with the final use, and the values are expressed in the numbers of pieces again. The value belonging to the light blue area are 0, and the values belonging to the dark blue area are greater than or equal to 0. And this depending on how many components from class group H and assembly groups from class group M are required for the final assembly of the steel construction. The green area, quadrant 3, is filed with such values that represent the initial cost of individual classes. The initial cost for individual classes can be obtained from a technological and economic analysis. If the current designed methodology includes modern cost accounting methods, it is clear that these values could be even more accurate. We will make the main calculation using the equation corresponding to the third task of input-output modeling, marked with the number 1. To calculate the cost per cost objects, use the equation marked with the number 2. On this page, we can see the complete input-output model completed with the internal turnover. To get the internal turnover, we multiply the values of the numbers of individual pieces in the classes concerned by the values obtained from the relation 2. Of course, we must multiply also the second quadrant of the input-output model by these values. This part also offers a more detailed specification of individual quadrants of the production input-output model. In conclusion, I give the assessment of the results obtained within individual chapters. Design analysis of the steel constructions. A new system of marking production drawing has been created here. Due to this system, we are able to classify appropriately individual components and assembly groups in class groups on the basis of their design and technological similarity. Technology analysis of the steel construction. An extensive analysis of production activities required for production has been carried out here. A thorough description and structuring of production activities create conditions for the implementation of modern cost accounting methods, to be specific modern ABMC methods, and modern management methods, to be specified critical path method and PERT. Economic analysis of the steel construction production. The number of individual classes has a direct influence on the size of the matrix that create the input-output model. The decrease in the number of these classes will have a positive effect, especially in the following areas. The reduced production prices of the steel construction, the sped up production process, the easy parameterization of the steel construction in the CAD software. Thank you for your attention, questions, and possible cooperation.
Hello everybody, my name is Bethany Williams,
and Marina Solet.
and today we'll be presenting our paper which is called A Taxonomy of Cyber Attacks in Smart Manufacturing Systems. So Marina and I have done research on cyber attacks that have taken place in the manufacturing sector over the last several years. We also looked into the cybersecurity framework for manufacturing, which was created by the National Institute of Standards of Technology, also known as NIST. Through our research, we discovered that all cyber attacks reported have not ever been connected to NIST. Thus, we decided to write a survey paper that makes a connection between NIST framework and as many cyber incidents as possible. In this survey, we had 4 main objectives. Explore the most common security challenges and attacks faced by the manufacturing sector. Also, apply the NIST manufacturing framework as a roadmap to reducing cybersecurity risk. We also wanted to raise awareness to manufacturers and researchers about security issues in the smart manufacturing industry. We hope that this paper will help others gain a better understanding of how to secure manufacturing systems through the creation of our proposed taxonomy.
For just a quick recap on how this term is actually defined, according to NIST, the National Institute of Standards and Technology, it is any fully integrated, collaborative manufacturing system that responds in real time to meet changing demands and conditions in the factory, in the supply network, and in customer needs. So, in simple terms, these systems use a technology-driven approach that use internet-connected machinery to improve the production process. It is being called the next industrial revolution, hence why you might hear it also being referred to as Industry 4.0. And thanks to the Internet of Things, never before have we had this much access to and contextualization of the data these systems analyze. Think of your smartphone only on a grander scale.
More people are moving towards smart manufacturing because of the competitive advantages it has to offer. Now, because of this, cyber attacks are increasing in frequency and sophistication within the manufacturing sector. These cyber attacks pose a significant threat to companies and organizations worldwide, and can cause damages to physical systems, delay production, or even create risk for human safety. Manufacturing was one of the top 5 most targeted industries in 2016, 2017, and 2018. Despite the manufacturing sector being one of the most targeted industries in the world, many manufacturers are not taking the appropriate security measures to be well prepared against cyber threats and cyber attacks. As a result, cyber attacks have caused the loss of over 40,000 manufacturing jobs in the U.S. alone. It has also caused the U.S. to lose as much as $70 billion in gross domestic product, which is a huge loss for our economy.
Due to cyber attacks posing such high risks, there needs to be a national standard that these companies look up to in order to secure these systems, whether it be processes or equipment, and ensure that they are optimized to enable cost-effective and agile manufacturing of these high-tech products and systems. This is where NIST comes in, as it is one of the nation's oldest physical science laboratories that promote U.S. innovation and industrial competitiveness. They are pretty much responsible for supporting and developing information security standards and guidelines for many industries, including, you guessed it, the manufacturing sector.
In what ways has NIST been involved in the manufacturing sector, you might ask? Well, NIST has created a cybersecurity framework for manufacturing, which helps manufacturers become more aware of potential security challenges, reduce cybersecurity risk, identify when an attack may be occurring, and learn how to recover from cyber attacks. This framework will provide manufacturing systems of all sizes, from big corporations to small-owned businesses, to have the same fundamental structure of security protocol and procedures, which will ensure protection against cyber attacks. It is aimed at reducing and better managing cybersecurity risk. The figure on the right shows the cybersecurity framework's 5 functions, which include identifying, protect, detect, respond, and recover.
In the development of this framework, or as they call it, the manufacturing profile, they included the identification of common business or mission objectives relevant to the manufacturing sector. These objectives provide the necessary context for identifying and managing cybersecurity risk mitigation pursuits. Key cybersecurity practices are later identified for supporting each business objective, which allows users to better prioritize actions and resources according to the user's defined needs. So let's go over them real quick. The first one is maintain human safety, which is being able to manage risks that could potentially impact human safety. The second one is managing risk that could adversely affect the environment, whether it be accidental or deliberate damage or both. The next one is being able to manage risks that can impact the quality of product, such as being able to protect against compromise of integrity of the manufacturing process and its associated data. The next to last one are risks that can impact production goals. Cybersecurity risk on the manufacturing system, including asset damage, could potentially adversely affect production goals. And the last one is managing risks that could lead to the loss or compromise of the organization's intellectual property and sensitive business data. In many of these cases, personnel should understand the interdependencies that exist between cybersecurity and these objectives.
NIST categorization process was developed to categorize cyber attacks based on their potential risk or impacts. There are 3 types of security levels: low, moderate, and high. Since these security levels allow attacks to be categorized by the significance of the threat they may cause to the manufacturer, this also allows manufacturers to prioritize specific needs for their organization. I'm sure you have heard of the CIA triad before, right? Well, NIST uses the CIA triad to analyze what type of impact a threat may potentially cause for the manufacturer. This means that confidentiality, integrity, and availability will play key roles in determining what security level a threat or attack may get categorized as. So, for example, the potential impact is low if the CIA triad is expected to have a limited adverse effect on manufacturing or operations, moderate if it's expected to have a serious effect, or high if it's expected to have a severe or catastrophic effect. This categorization process will be influential in helping manufacturers and other organizations decide what security measures need to be implemented to ensure proper protection.
In our paper, we shared our own perspective and thoughts of how NIST framework can be seen solely through the lens of cyber attacks. Through their manufacturing profile, it is believed that cyber attacks can be mapped to both the manufacturing objectives and the categorization process based on security levels. Why are taxonomies important, you might ask? Well, it's always important to review and analyze cybersecurity issues within any sector in order to properly address them. By mapping cyber attacks with the manufacturing objectives, one can see how cyber attacks can affect the different missions of manufacturing systems, therefore allowing both researchers and manufacturers to see how to identify which objective is being targeted. This will give a clearer categorization of cyber attacks based upon their framework, and thus would enable one to develop preventative or responsive approaches based upon the attacks mentioned in the proposed taxonomy.
This is a diagram we created to represent the structure of what our taxonomy looks like. As you can tell, the first layer of our taxonomy consists of 5 categories, which are NIST manufacturing objectives, including human safety, environmental safety, quality of product, production goals, and trade secrets. Now, we know that some cyber attacks could affect multiple of these categories, or the attacks could simply affect only one of the objectives. However, in our taxonomy, we decided to categorize the attacks in one objective or another. We also have other layers of the taxonomy, which will be described on the next slide. So these are the attributes that we added to the taxonomy. They include the incident itself, the attack mechanism that the attackers use to attack the system, the level of impact, which we discussed can be either high, low, or moderate. We also included actors, so those who attacked the system or tried to cause harm to the system. We included the CIA violation, so did the attack affect confidentiality, integrity, or availability. We also put the type of threat, which can include deception, disclosure, disruption, or usurpation.
So let's start with the first dimension. The first category we talked about was human safety. You have incidents such as the Jeep Cherokee ignition switch hack that happened in 2015, where it was announced that hackers had taken control of a Jeep Cherokee through its internet accessible entertainment system. The vulnerability impacted over 1 million vehicles purchased in the US, which had been equipped with the company's Bluetooth system. And the hackers were able to do that by using a technique classified as a zero-day exploit, which allowed them to execute code that allowed them to wirelessly break into the vehicle system and grant them access to control vital functions such as steering, brakes, and transmission. You also hear about the one that occurred in 2017 when it was announced that an oil and gas petrochemical center in Saudi Arabia had experienced an emergency shutdown as a result of a malware attack. The malware, termed Triton, also known as Trices or Hatman, exceeded other industrial cyber attacks by targeting safety instrumented systems into running unauthorized programs on the safety instrumented system. The incident resulted in millions of dollars in lost production and posed as a threat to human life, as dozens of people could have been killed.
In this part of the taxonomy, our main concern is what effects cyber attacks might impose on the environment. I'll start with a low-impact attack that occurred in 2013 on a New York dam. In this attack, a small group of Iranians were able to access information about the dam's operations, like the water level, the temperature, etc. However, they were not able to cause any physical damages to any aspect of the dam. Imagine if this attack occurred on a big dam like the Hoover Dam. This could have caused large-scale flooding in urban and rural areas throughout Nevada. Another moderate impact is related to a U.S. turbine control system. In 2012, a computer virus was on an employee's USB drive and infected the computers on the system's network. The malware attempted to steal classified information but resulted in serious economic loss due to the plant being shut down for 3 weeks. This cyber attack can be classified as a moderate impact incident due to the plant's activeness in recovering from the incident because it did not restrict the plant from producing electricity.
The third part of the taxonomy had to do with security events that dealt with the quality of product being tampered. You have one that happened in 2016 when malicious actors successfully penetrated a water utilities logic control system and altered the levels of chemicals being used to treat tap water to make it safe for consumption. The group was able to compromise Camry Water Company's computers after exploiting vulnerabilities in its internet-facing customer payment portal. The hack, which involved SQL injection and phishing, was made easier because login credentials for the operational control system were stored on the web server. And the last one on this list occurred in 2017, and is probably one of the most well-known attacks, and it's the WannaCry virus. It started simply as a ransomware worm, spread swiftly across a number of computer networks. The massive global attack infected more than 300,000 computers in over 150 countries around the world. And how exactly did they do that? The ransomware took advantage of a security vulnerability in Microsoft's operating system. The crypto worm, after successfully infecting a Windows computer, would encrypt files on the machine's hard drive, making them inaccessible for the user, and it would then pressure the victim into paying a ransom payment in order to decrypt them.
The next cyber attack that I'm going to discuss is probably going to relate to production goals. So the first one is probably the most famous cyber physical attacks that have ever occurred, and it is known as Stuxnet. Stuxnet is actually a computer worm that destroyed nearly 1/5 of the centrifuges at an Iranian nuclear plant. The attackers gained enough access to change the displays of the machines to cause misreading values. This attack caused a tremendous amount of physical damage to the machines. Finally, in 2019, one of the world's largest aluminum manufacturing companies was attacked through the use of ransomware, called LockerGaga. The ransomware accessed and encrypted data on all the devices it infected. By infecting 40 sites of the company worldwide, hackers were able to gain enough access to shut down both the manufacturer's production system and their network. All automated manufacturing systems were stopped and had to be manually operated. The attack caused the company to lose between $50 and $54 million and significantly reduced the production process.
And last but not least, our fifth dimension is trade secrets. Third on the list is Deloitte, one of the world's big four accounting firms. In 2017, they reported a massive cybersecurity data breach. Hackers were able to gain access to the email server, and this allowed them to obtain valuable information such as usernames, passwords, IP addresses, business information, and even workers' health record. This attack led to major security concerns about Deloitte's email systems and servers. And lastly, in 2013, Target discovered an extensive data breach. Hackers were able to gain valuable information about millions of customers. Specifically, the attack led to the theft of approximately 40 million payment card records, along with 70 million other information records, such as addresses and phone numbers. Having customers' information exploited in that way and exposed to people worldwide would cost Target millions of dollars.
To understand potential vulnerabilities and protect manufacturing system standards, we developed a taxonomy in which we presented today. The proposed taxonomy lists a variety of cyber attacks that have occurred throughout cyber history, but also uses the NIST framework cybersecurity manufacturing profile to categorize attacks, with our addition of proposed taxonomy attributes, including the attack mechanism, CIA violation, and the attackers who performed the attack. We hope that using this framework, researchers and organizations can categorize cyber attacks in a more accessible manner to create awareness about the damages caused by the attacks.
Future research opportunities in this area could include incorporating mitigation techniques for these type of cyber attacks with the NIST standards and framework, and improving vulnerability and risk assessments. Most of these attacks mentioned in the taxonomy could have been prevented if better security protocols were in place. The taxonomy will provide the manufacturing industry with a deeper understanding of how to better secure smart manufacturing systems. Thank you for your time.
Hello to everyone. My name is Miroslav Kostadinovic and I am from the University of East Sarajevo, Faculty of Transport and Traffic Engineering, Doboj, Bosnia and Herzegovina. I'm a first author of the paper analyzing performance of wireless network based on the industrial HART protocol. Other authors are Dalibor Dobrilovic, Gordana Jotanovic, Goran Jauševac, Željko Stojanov, Vladimir Brtka. Our email addresses are presented on the last slide so that you can contact us due to the paper related information or future cooperation. Modern control systems in the process industry increasingly use wireless data transmission to send out information from a sensor located directly at the site of a process to the central control unit. There are numerous reasons for such an approach. The most common reason for choosing a wireless industrial communication network is the cost of installation, since eliminating or significantly reducing cable usage means significant savings in cable and installation work. In other words, the cost of new installation, maintenance, and repair is lower than the corresponding cost for cable solutions. And wireless technology opens up a new field of application in terms of how measured process data is transmitted. Costs in wired networks can be even higher if there is a need to expand existing infrastructure to include additional measurements. While adding new measurement allocation in wireless networks represents a small cost and significantly reduces the economic barrier that exists in wired networks. The application of smart manufacturing systems and the expansion of the Industry 4.0 model have created the need to modernize existing industrial environments. One way to modernize existing factories is to use wireless technology in monitoring, controlling, and managing industrial processes. The applicability of wireless HART technology in the industrial environments as a wireless technology capable to support system requirements is investigated in this paper. The rest of the paper is organized as follows. Section 2 gives some insight into related work. Some details on IEEE 802.15.4 standard and wireless HART are given in Section 3. The approach of the wireless HART system is described in Section 4. Section 5 describes the experiment of wireless HART performance analysis as well as results discussion, while final Section 6 gives the conclusion and possible future work. Wireless HART and 802.15.4 overview. Wireless HART is a wireless sensor networking technology based on the Highway Addressable Remote Transducer Protocol, or HART. Wireless HART is based on the physical and MAC layers of the IEEE standard 802.15.4. The IEEE standard 802.15.4 defines the physical and MAC sublayer for low-rate wireless personal area networks. The standard specifies physical as it is shown in Figure 1. Wireless HART system architecture. The number of devices that can be connected to the wireless HART network via the wireless gateway depends on the update interval of the data that the device sends to the wireless gateway. For example, if each device in the wireless HART network sends updated data every 60 seconds, then the wireless gateway can support up to 100 devices. The maximum allowed update interval is 1 hour. Update intervals shorter than 60 seconds are predefined in exponents of number 2, such as 4, 8, 16, or 32 seconds. However, the shorter the update interval, the shorter the battery life. Practically, the shortest update interval for this generation of equipment is 8 seconds, although there is a choice of 4, 2, or 1 second. In the closed space of the industrial environment, There are obstacles that are on the line of communication between the devices within the realized wireless network. The enclosed space architecture with the marked wireless gateway position and the numbered device positions, wireless transmitter or node, together with the indicated distances between them, were organized for the experiment. The wireless HART architecture shown in Figure 2 contains the following elements. Number 1, it's a host system. Number 2 is wireless gateway, and number 3 is wireless transmitter. Host system consists of the host computer and appropriate software applications that allow monitoring, control, and management of industrial processes. Data collected with the help of wireless HART does not always belong to the control system, as some measurement points can only be used for monitoring or management. They can also be used for real-time control in certain applications. Host systems should be such that data packet from the wireless HART network is delivered to the host computer via the gateway. Wireless HART data can be routed through shared network resources, like data collected on liquid level in industrial tanks, data collected on the vibration spectrum, data collected on fluid pressure, data collected on the temperature state of the observed industrial systems, and so on. Wireless gateway. Wireless gateway is very important when designing a wireless HART system. The wireless gateway connects wireless self-organizing networks to the host system. The reliability of wireless gateway is ensured by the IEEE 802.15.4 radio standard, 2.4 GHz ISM band sliced into 15 radio channels with time synchronized channel, hoping to avoid interference from other radios, Wi-Fi and AMC sources. Important characteristics of the wireless gateway are easy configuration and management of self-organizing networks, easy integration into control system and data applications via serial and Ethernet connections, and wireless capabilities are expanded with the advantage of using in inaccessible locations. Wireless transmitter. Wireless transmitter are devices that connect to the gateway and enable fast, reliable, and secure data transfer. Often the wireless transmitter includes sensors that gather information from industrial environments. Wireless HART devices include wireless transmitters with temperature, pressure, flow, level, and other process variable sensors. Wireless transmitter in the wireless network offering dual-channel discrete inputs and discrete outputs. Discrete single or dual switch input with logic for limit contact and opposing contact applications. And dual channels are each configurable for discrete input or discrete output. Here we can see results and discussion. The experiment took place in a laboratory environment. The experiment setup is as follows. The wireless gateway is placed on the wall in the far left wing of the laboratory as it is shown in Figure 3. The wireless transmitter or node 2 is placed in the fixed location near the wireless gateway. The wireless transmitter or node 1 is portable and it is used to test the wireless HART network performance at 4 different distances of 5, 10, 20 and 30 meters. The results of the tests are presented in the following tables. The overall network statistic is given in Table 1. Each location displays the results for Node 1, Node 2, and wireless gateway respectively. The results are for the number of neighbors connected, reliability of the links, missed updates, path stability, received signal strength indicator, and joins. The results give the similar values of RSSI for different locations, giving the conclusion that according to the results, the distance in this area of coverage does not have significant influence on the RSSI level. Table 2 shows the results for the node 1 statistics. Here the results are focused on RSSI values in direction to and from the neighbor. The results are slightly better for the distance of 5 meters and slightly worse but almost equal for other distances. The path stability is almost 100% in each scenario. Table 3 shows the results for the node 2 statistics. Here the results are almost similar as table 2 for node 1. The only difference here is the better results for 30 meters of node 1's signal strength comparing to shorter distances. This small deviation from the expected results can be explained with the institutional or building layout, like wall, furniture, and other obstacles. Table 4 shows the results for the burst statistic with the focus on latency in the network. The latency here gives the very good results. This is of high importance for the planning possible applications of wireless HART in the given system because the latency is crucial for optimal network performance in given system. Table 5 shows the results indicating overall network performance. Here the most important parameter is the number of burst messages, showing the intensity of network traffic. Again, average latency in 15-minute interval and latency lifetime are very good for potential usage of the system. Conclusion. In this paper are presented test results and the usage of wireless HART technology in the industrial wireless sensor network. Industrial wireless HART system must have a consistent node connection to the gateway regardless of obstacles in the environment. Consequently, the latency and general network performance are of great importance for the response of the entire system. In the experimental wireless HART system, the problem of signal transmission obstacles was solved by introducing node 2, which allows a redundant path between gateway and node 1 for different distances. In this case, the latency has low values and the communication between the node and the gateway is better with a low transmission packet rate. Also, the experiments with wireless HART technology are interesting because this technology is based on IEEE 802.15.4 physical layer, designed especially for wireless personal area networks. This proved to be important for ZigBee, wireless HART, 802.15.4G SUN, 6 low VPN, and so on. The experiments took place in laboratory environment with 3 nodes. 2 nodes were fixed and 1 node was portable. Results and discussion presented in section 5 justified the applicability of wireless HART technology in the industrial environments as a wireless technology capable to support system requirements. The wireless HART, with its features such as low latency and low packet error rate, low number of errors on the specified distances, showed to be highly applicable in the system for the industrial monitoring. The most important performance parameter analyzed in this research is latency. The low latency values justify the applications of the wireless HART in the given system because the latency and better network performance in general are crucial for the fast response required in this system. In the future work, the coexistence of the wireless HART with other wireless technologies operating in the 2.4 GHz band, like IEEE 802.11 and Bluetooth Low Energy, should be examined as well. Thank you for your attention. Do you have any questions for authors? The authors' email addresses are on the first and last slides.
Hello from the AI team. We have a great new feature in the AI Compass that you can use. Upvote your favorite presentations to show appreciation and respect to the best presenters. Open up the EAI Compass, go to the program, find the presentation you want to upvote, and hit the thumbs up button. It's that simple.
Hello everyone, my name is Petra Zoric and today I will present you the paper entitled Modeling the Purchase Process of the IoT Shop Solution in a Store Environment that I wrote with my co-authors Dragan Perakovic, Marko Periša and Ivan Fritis. First of all, I will just say something short about myself. My co-authors and I are employed at the University of Zagreb, Faculty of Transport and Traffic Sciences, at the Department of Information and Communication Traffic. I am a PhD student and I am a publicity and social media chair of this year's conference. So the research overview for today's presentation is as follows. I will tell you something about our research motivation, present you IoT shop system architecture and value chain, present you business scenario, talk about ecosystem and business model, and tell you my final thoughts. The independence, which is one of the biggest factors for normal everyday functioning of the person with disabilities, is possible with assistive technology development application, which leads to easier overcoming of obstacles. One of the example of innovative solutions for assistive technology for a visually impaired person is smart shopping cart. In 2016, smart shopping carts for the visually impaired appeared for the first time in India, and it had a tablet in their offer that displayed the prices of products and their characteristics. Scientific research dealing with innovative information communication services and systems in a smart trade environment is increasingly focusing on sensor technologies and networks, especially RFID and ZigBee. Currently available scientific papers are mainly based on developing information and communication services product systems for the visually impaired conceptual or prototype level. And my co-authors and I have noticed that these papers do not have developed business models for specific solutions that they develop. So this paper focuses on proposing a business model based on the conceptual architecture of the IoT shop solution that is related to informing visually impaired people through an intelligent store environment. This paper aims to model parts of the IoT shop solution using the Transformation Accelerator modeling tool to develop a business scenario and business model and apply the ecosystem. The conceptual IoT shop architecture is shown through layers on this slide. You can see the perception layer where sensor nodes route data through the network layer using access points and gateway to fog, cloud computing, and storage. The data collected in the sensor nodes are located on the sensors installed on the shopping cart and in the shopping store, such as RFID tags, weight, beacon, etc. In the middleware layer, data collection, fusing, processing, and storage of collected data occur. The billing process occurs in the business layer, while the necessary application solutions for the IoT shop service to end users are located in the application layer. It is important to say that company called IoT Solution develops the IoT shop service. Service providers could be network infrastructure service providers or network provider and content service providers, like in IoT Solution in this case. The network operator provides the necessary network infrastructure for service delivery. The required user equipment is a mobile device on which a mobile application is implemented that provides access to the necessary information and whose design contains universal design elements. we divided functionalities offered by this solution into functionalities that are available through the mobile application and through the cloud infrastructure application, and they all are executed in real time. The equipment located in the eNIOT store within which the eNIOT shop service is performed contains several information and communication subsystems like smart card subsystem, application subsystem, and cloud computing subsystem. There is also the possibility of expanding the system by adding new services for the end user. The concept of service offering is based on the cloud computing concept, whose purpose is to provide everything as a service. In this example, eNIOT solution develops the platform as a service model of eNIOT shop. The services available in this model are shown on this slide. The basis for developing a business model is a value chain because it explains how business models are created and developed. In the business process proposal from this paper, stakeholders of the value chain of delivery of the eNIOT shop service are these presented on this slide. The user represents a blind or partially sighted person who uses the proposed eNIOT shop service to perform purchasing activities within the custom eNIOT store. User can also be a person without disabilities or an elderly and slow-moving person. Network provider enables the use of network data traffic technology for eNIOT shop users and in eNIOT store. eNIOT solution is a company working on the development, implementation, and maintenance of eNIOT shop solution. Equipment suppliers are companies that enable the procurement of the necessary equipment for the development of solutions. Support service is responsible for resolving difficulties that may arise when using this solution and is a separate part of eNIOT solution business. eNIOT store is an intelligent store that offers cards equipped with a network of sensors and actuators. Each of these stakeholders can be assigned roles that specify the meaning of each stakeholder within the transformation accelerator tool. It is possible to define three business scenarios in this case: user and mobile application scenario, a smart store scenario containing a smart card and mobile application, and cloud computing infrastructure scenario in which the focus is on mobile application and cloud infrastructure application. The information and communication system for the delivery of the eNIOT shop service can provide the possibility of service delivery in three different scenarios and is made up of a union of these scenarios. For the development of the business scenario of the eNIOT shop service, it is necessary to identify added values and key drivers and make a SWOT analysis of eNIOT shop service development. The added value relates to the innovation that eNIOT solution promises to provide to the users of their service if users choose to use it. Depending on the business scenario being observed, the added value can be divided into three parts. First is for user and mobile application scenario. The added value is, for example, safe movement or accuracy of the information. For smart store scenario, the added value is market competition or socially responsible business. And for the cloud computing infrastructure scenario, these are content customization, real-time information, modularity, etc. The key drivers can thus give a big impact on whether a company is doing well or not, and they can also point to problems of poorer performance or business results. The key drivers of solution development are these that are mentioned on this slide, and every one of these drivers is important. These key drivers is important for functioning of our proposed solution. SWOT analysis aims to identify the strengths, weaknesses, opportunities, and threats of the INIOT shop service. The ability to ensure the independence of the user is one of the greatest strengths of the INIOT shop service, as it raises the user's self-confidence and eliminates the need for other people or aids. It is essential to ensure the privacy of users, which poses a threat to the proposed solution, because it is not possible to say with certainty that an attack on the system will not happen. The other elements of the SWOT analysis are presented on this slide. You can see here the ecosystem model of the INIOT shop service that is focused on the user's mobile application and is created in the Transformation Accelerator tool. It doesn't show the whole possible solution and data flows. INIOT shop service is at the heart of the ecosystem. There are additionally added stakeholders that are not previously mentioned for a more detailed presentation of the model. I will briefly introduce you to this model. INIOT solution develops the INIOT shop service and offers it to the INIOT store. Investors invest in the development of INIOT shop. The proposed solution involves placing a mobile application on the Play IoT store to download the application to their mobile device. INIOT solution notifies the support service of all changes related to the INIOT shop service, which is responsible for reporting changes to applications, difficulties related to the use of the service, and notifying the factory in charge of manufacturing cards of sensor problems and interruptions. It is available at all times to solution users and in IoT shop. Equipment suppliers supply the necessary equipment like sensors for smart cards to perform the service on time. The network operator provides the necessary telecommunications infrastructure for the INIOT shop. Once the user has collected the desired product, payment must be made. In doing so, INIOT shop sends a payment request to the payment service provider, who then responds to the request by approving or rejecting it. And in the ecosystem designer module within the Transformation Accelerator tool used to model the ecosystem, it is possible to show the relationship between the stakeholders on the business scenario from 5 points of view. And in this picture, they're marked in different colors, so that green represents the financial relationship, and orange represents the data being exchanged, purple represents the products or services, blue indicates the contractual relationship, while pink represents the operational relationship between stakeholders. The business model must provide business benefits among all stakeholders in a predefined value chain of service delivery. The elements that influence the development of the business model are marked blue on this slide. Key partners have the task of optimizing operations and reducing risks. The key activities are marketing, increasing the number of trading partners, maintaining solution, and cooperating with partners. the task of key resources is to create value for the end users. Value propositions represents the benefits that the solution provides to facilitate the purchase process. The stakeholders affected by the company solutions are the malls and malls customers. There is also marketing channels that can present the solution to end users. Users can generally be segmented into blind people, visually impaired people, and other groups of users without visual impairment. The cost structure refers to the financial costs for the company, and revenue flows indicate the elements based on which the company generates the revenue, such as participation in tenders, grants for innovation, and retail chains that implement the proposed solution in their stores. To conclude, every person who has a visual impairment and moves without assistance faces numerous challenges every day when overcoming obstacles. Currently, there are not many solutions on the market that are in the function of overcoming the daily obstacles of these groups of users. These solutions require high costs of investment in development and maintenance, while on the other hand, there are a small number of potential users, which is why it is necessary to find a sustainable business model. The Transformation Accelerator tool was used to develop the business model and business scenarios of the in-IoT shop service, and also to apply ecosystem elements that are focused on the user's mobile application. When designing the in-IoT shop service, it is essential to apply universal design principles to allow easy use of the service for all groups of users for whom the service is intended. The development and implementation of the in-IoT shop service can lead to an increase in the quality of life and the degree of independence of people with visual impairments, and lead to an increase in the degree of integration of these people into society. Future work will focus on the processes that take place between in-IoT shop service users and a smart card. You can see the picture of my co-authors in case you don't know them, and our email addresses. Contact us contact us if you want some collaboration or have some extra questions about this topic. Also, there are links to our faculty and department where you can inform about our work. Thank you for your attention, and enjoy in the rest of the conference.
Ladies and gentlemen, let me introduce you our research about polyvinyl butyral as a significant material used by additive manufacturing. The additive manufacturing is the computer-controlled sequential layering of materials to create three-dimensional shapes. The most common areas of application of additive manufacturing are in the aerospace industry, tooling, and engineering, automotive, and the medical industry. The most benefits of additive manufacturing we see in the accelerated prototyping, customization, energy saving, environment benefits, inventory stocks reductions, manufacturing and assembly, material waste reduction, and production flexibility. The aim of our research is that the waste of raw materials of windscreen films thus represents new possibilities for its application to various areas of industry. Due to the already definite advantages of this material characterized by available processing technologies and low input cost, it creates and will create a high potential for usability. The development tendencies of the material are both in the field of study and testing and their direct application in the practice. As a part of research into the recycled polyvinyl butyral, we plan to minimize problems with waste material from car windshields, reuse into production processes, and by processing recycled polyvinyl butyral into new materials to implement them into selected production of engineering products, not only there. Polyvinyl butyral is our key material, and polyvinyl butyral, which forms a safety interlayer in car window or building windows through recovery technology, mainly in material recovery, takes the form of flakes that have dimensions of from 2 up 20 millimeters and thickness of 0.5 to 1.5 millimeters. The polyvinyl butyral recycled in this way was contaminated like dust, glass fragments, so it was necessary to wash and dry the material before starting laboratory work. As a part of the work, polyvinyl butyral in the form of granulates was used for our research. As we can see this in the previous picture, number 3, then we used the polyvinyl butyral in the granulated form. The shape of recycled polyvinyl butyral, we used the granulate color was white gray sized from 20 to 30 millimeters. The purity was more than 97%. Impurity content less than 3%. Residual humidity circa 2%. The proportion of glass contents particle, it was less than 2%. And in the next slide we can see the analysis we used by our research, and it is going about differential scanning calorimetry. Differential scanning calorimetry, or shortly DSC, or differential compensation calorimetry, is a method in which the thermal properties of materials are examined. The method is widely used to determine melting points, glass transitions, and crystallization of various materials. It finds specific application in the study of polymers, emulsions, reactions, kinetics, or thermal conductivity of materials. The standard temperature range of the instrument is from -100 to +600 Celsius degree. Differential scanning calorimetry method of measurement consists of a content heating, cooling rate of 2 vessels. One vessel is empty. It's we know it like a reference sample, and the other contains the sample. The control unit, in this case computer, constantly ensures a constant heating rate of both samples through the experiment. Typically it is going about 10 Celsius degree per minutes. Since one vessel is empty and other contains the sample, the heat flux to the individual vessels will vary due to composition of the sample and the fast change taking place in the sample. In differential scanning calorimetry, we focused on determining the glass transition and melting point. The weight of analyzed sample was 9 milligrams. The test temperature ranged from -50 degrees to 300 Celsius degree. The measurement process itself began by cooling the sample from -180 Celsius degree and then heating it. The key temperature to start the analysis was -50 Celsius degree. The sample is heated only after reaching a temperature of +300 Celsius degree. By using this analysis of differential scanning calorimetry, the sample is subjected to linear heating and thus to the heat flow rate, as we can see in the graph. The heat flux is proportional to the specific heat. Inside the measuring device, the internal temperature equal to the room temperature. It is going about 20 Celsius degree. Two symmetrical vessels were stored. The instrument includes a residence thermometer and a heating element built into the sample carrier and serves as the primary control of the system. The following graphs represent the data obtained after differential scanning calorimetry analysis of recycled polyvinyl butyral samples. The temperature of the sample is maintained isothermally with the reference. Such an amount of energy is needed to maintain isothermal conditions. The curves are plotted as a function of time or temperature. Small samples were used for analysis. The material is placed on a metal pad which reduced the thermal gradient to minimum. Within the analysis, it was possible to use high heating rates, thus ensuring a high resolution of heating and therefore the obtained temperature range. Additive manufacturing is one of the basic supporting technologies that shapes new approaches to manufacturing and the products and plans of the future. At the present and in the future, not excluding, the priority will be respect and incorporation into the product design of customer requirements. We know it as mass customization. The use of recycled materials in additive production or in additive manufacturing is conditioned mainly by the qualitative properties of the input material. Our priority is to work with the plastic waste which we recycle using appropriate technology, like a plastic flocks or granulate. Greater design freedom leads to the new generation of products like almost unlimited design freedom can bring a wide range of benefits in different areas like automotive and aerospace industry, healthcare, machinery and equipment, sports equipment and the lifestyle. By our research, we used recycled polyvinyl butyral. It is an important component in producing on the new materials. It is characterized by very good elasticity, adhesion to various surfaces, good water resistance. The advantages of material is high compatibility with other polymers and very good possibilities in producing composite materials. It was these properties that were key to the possibility of using polyvinyl butyral in additive manufacturing. Our research was focused on testing the physicochemical properties of recycled polyvinyl butyral using differential scanning calorimetry. By our research, by implementation of the material from secondary raw materials and their applications, The possible final parts fully support the economic and environmental aspects, which is so important, not only today, but we have to see to the future. Thank you so much for your attention, and in case of any questions, please feel free to contact me via my email. Thank you so much. Dear ladies and gentlemen, I would like to present the paper on the specifics of silver generation shopping behavior in the selected cities of Western Slovakia. The authors of this paper are Professor Alena Dubcová from the Konstantin the Philosopher University Nitra and Miroslava Trembošová, Dr. Trembošová. They are both from the same workplace, and Professor Ludmila Naďová from Slovak University of Agriculture in Nitra, and me from the Faculty of Material Science and Technology, the Slovak University of Technology in Bratislava. Slovakia is characterized by the aging process of the population. Aging, it is not necessary to perceive as a threat, but rather as a thoughtful possibility of active aging. So, generation 50 and more is known as the silver generation, which is mainly made up of a generation known as the baby boomer. It includes a generation of younger seniors, 50, 60 years old and over 65 years old. This generation is a strong group of potential consumers, and it is therefore necessary to pay increased attention to it, in particular to its claims and requirements, including retail. The aim of this paper is to identify the factors that determine the choice of shopping in retail entities, determine the types of shopping behavior of both types of silver generation, and point out their specifics in two regional cities of Western Slovakia, Nitra and Trnava, characterized by automotive industry. The paper is based on behavioral survey conducted in both regional cities and evaluated by the standard methods. As far as theoretical background, seniors' share in the total population is growing. The population has considerable shopping power of accumulating savings, and increasing consumption is becoming significant and promising for the market. The baby boomers is perceived as sandwich generation, but also have responsibilities to their still living parents, which affect the redistribution of its wealth. As far as behavior of senior consumers, we can say that seniors are interested in new products, but not for the satisfaction of specific personal needs, biophysical and psychosocial in older age. Seniors with increasing age have limited ability to use additional information and rely more on memory experience. Older people are more sensitive to product prices, and seniors have a higher loyalty to retail outlets, and seniors prefer the convenience and simplicity of products. As far as methods and the data, behavioral surveys make it possible to obtain so-called soft data. And the data obtained from the field of survey conducted in Nitra in 2015 and in Nitra in 2014 were used to analyze the shopping behavior of the silver generation. By the silver generation, it is meant the population of post-production age over 50 years, which we divided internally into two groups, group 50 and 60 plus. And the respondents were approached outside shopping centers to avoid being directly involved in influence. The polls were mainly streets, pedestrian zones, and bus stops, and consumer respondents' preferences and opinions were evaluated by classical method, comparative analysis based on description, as well as statistical, graphical, and cartographic methods. As far as the questionnaires, they were divided into three basic parts. The first part was focused on knowledge of the respondents' demographic characteristics, gender, age, educational attainment, occupation, permanent residence. In the second part of the questionnaire, the respondents determined the factors by selected domains that affect them when shopping. And in the third part, at their own discretion, they were included in different types of consumer behavior based on methodology of the company JFK Praha. Shopper, typology, media, behavior. Modern shopping orientation consists of three subtypes of customers: influential, demanding, and mobile. And the traditional shopping orientation consists of four shopping subtypes: conservative, saving, loyal, and unpretentious, phlegmatic. You can see that the study areas was Nitra. Nitra has population 80,611, and it is on 187 square meters. And in Nitra, respondents were addressed, and 109 were in the category 50-60, and 108 in the category 60-year-old and older. As far as Trnava, King Bela IV gave Trnava royal privileges, and as far as population, it's about 65,000, and it is on area almost 72 square meters. And there were 220 respondents, of which 111 were younger, and 109 older seniors. So they have a similar development in population, position in the settlement system, administrative function, historical development, traffic position, as well as local economy. As far as the results, you can see they are as follows. Between 2001 and 2015, 9 shopping centers were built in the serviced cities, of which in Nitra 4 and Trnava 5. According to the location, 3 of them were Centro, Max, and Gallery, belong to the type according to the classification out of center. And in Trnava, there are 5 shopping centers with a total gross rentable area about 83,000 square meters. Of these, 3 are out of center, and the new shopping center of Trnava is City Arena, opened in 2015, which is unique in Central European space in connection with a football stadium and is included in the end of center type. The centers like Max, Gallery, and Arcadia belong to the out of center type, and depending on the spatial character, it is a mixed type 1 and 2 sites characterized by spatial proximity to customers' homes and competing companies. The mall Trnava belongs to the group of shopping centers H Town. So far, both cities as centers of the automotive industry are significant centers of commuting from the territory of Western Slovakia, and also centers of trade. The most significant is the daily commuting from their background. Inhabitants who commute to work use their services, healthcare, education, and others, while at the same time making purchases of daily and durable goods, increasing the pressure on retail services, especially on shopping centers near bus and the railway stations, as you can see in the graphs. As far as basic characteristics of respondents in Trnava and Nitra, we can say that the silver generation group consisted of 437 respondents over 50 years, and both cities are represented by almost balanced share in the number of respondents. Nitra 49.66% to 50.34%. And the segment of younger seniors consisted of 220 respondents, of which in Nitra 109 and in Trnava 111. The segment of older seniors was formed of respondents over 60 years old. And this group consisted of 217 respondents, of which 108 in Nitra and 109 in Trnava. Among the seniors, women have a more prominent position in both cities. Women achieved 57.67% of the sample studied, and it is generally known that women buy rather than men, which has been reflected in this generation. There were 1.32 senior women per one senior buyer, and the ratio of respondents in both cities was almost balanced. Nitra 128, Trnava 124, as in both categories of seniors. And Trnava and Nitra are all centers of the secondary and higher university education, which was reflected in the structure of seniors according to the achieved education. And most respondents, 77.8%, have completed secondary education. And as far as higher education, it is represented in 8.24%, and primary education in 13.96% respondents. And the silver generation is specific to the job structure. Segment 50-60-year-old, younger seniors are involved in work, are in the progress of preparing for retirement, of which 15.9% are retired, especially premature. The age group 60 and over is made up mainly of pensioners, 93.55%. However, working pensioners, about 6%, are also represented in the group. Factors affecting purchasing. For everyday shopping, the majority of seniors prefer to shop in retail units closest to their homes. In the case of employed seniors, retail establishments located in the vicinity of the workplace are mainly focused on selling food. And the price of goods is one of the decisive factors in choosing a retail store alongside the location retail facility. They are also a primary factor for the seniors of both studied urban segments. Internal response structure of seniors is differentiated, and the price of younger seniors is higher when shopping in both cities, while older ones, the location and its accessibility by public transport, Trnava about 48%, Nitra almost 33%, and then Nitra 35.97% and Trnava 29.37%. So as far as monthly household income of respondents in Nitra and Trnava, you can see that the table shows that the vast majority of respondents manage incomes up to 1,000 euros. Nitra 62.67%, Trnava 72.73%. 50-60-year-old segment achieves higher household income than older seniors. It is a question of wages, which is always greater than retirement. Monthly incomes up to 500 euros are characteristic for almost half of 60 or more years old respondents. And in both towns, this income among older seniors is relatively equally represented. Nitra 49%, Trnava 49%. The growth in monthly household incomes decreases the number of respondents. And in a household with older seniors with incomes from 500 to 1,000 euros, 40.74% of respondents in Nitra and 32.11% of respondents. As far as structure of types of shopping behavior of seniors in Nitra and Trnava, we can say that the older generation tends to the traditional type of shopping, which shows a significant share of savings and loyalty, which is also reflected in the seniors of Nitra and Trnava. And 82.3% of respondents were included in the traditional type in Nitra and 78.18% in Trnava. More than 1/5 of respondents have integrated into a modern type of shopping behavior. They were 21.82% in Nitra and 17.97% in Nitra. In both cities, in modern type of shopping behavior are also represented by its subtypes, influential, demanding, and mobile pragmatism. The modern type is more pronounced in the group of younger seniors, 31.11% of respondents in Mitra and 26.76% in Tanava. So, finally, conclusions. Generation 50 years and over, known as the silver generation, with an increasing labor shortage, it has become an increasingly important economic and social force whose position in society is growing. This generation, not homogeneous, is intrinsically diverse, not only in terms of age, but also in terms of its characteristics and needs. Already today, they form a strong group of consumers who are not giving adequate attention. And the decisive factor is also the price of the goods, which is associated with various promotion of retail facilities to attract customers. And older seniors also prefer shopping in stores with a familiar atmosphere, which is created by the speed of service and its willingness, the size of the store, but also arrangement of goods, etc. They treat them loyally and often visit them. Seniors tend predominantly to the traditional type of shopping with a smaller proportion of the modern type. This shall reflect the interest of the younger segment of seniors in particular. Dear ladies and gentlemen, thank you very much for your attention.
Hi everybody, my name is Marko Karstic. I'm Innovation Associate at Algois Ltd Cyprus. I will talk about challenges and benefits for detecting soon-to-fail drives in Industry 4.0. This work is partially supported by European Union Horizon 2020 Innovation Associate Grant Pre-Fail and by Cyprus Research and Innovation Foundation under the grant agreement postdoc 09160090. Industry 4.0 storage requirements are becoming more stricter by involvement of new technologies, emerging technologies in industry like big data, cloud computing, Internet of Things. Nowadays, the analysis and processing of data is not only in data centers but also in so-called edge data centers nearby at factories, nearby to the sensors and Internet and things that are source of data and processing. Because of that, the performance and reliability of storage devices must be improved. One way for doing this is by using proactive monitoring and systems and detection of soon-to-fail drives. But there are some challenges also in developing system for detection of soon-to-fail drives. Usually there is a high level of noise in data set because of non-standard values of attributes used to description of drive performance. And also there is extremely class imbalance distribution because the number of failed drives in dataset is much smaller than number of healthy drives, and also the failed drives shows the soon to fail behavior only before the failure, not during the whole life cycle. There is also concept drift, the function that describes relation between attributes and outcome soon to fail, non soon to fail, are changing during the time because change of class imbalance ratio, but also because of inclusion of new drives with different behaviors. And lastly, there is a big data problem because datasets contains a large number of drives, and the heterogeneity of these drives makes the problem more harder because global model must be able to predict the common relationship between attributes and the outcome. We divided our methodology in different steps. The first step was data processing. We selected the backbase data set as to emulate the behavior of drives in Industry 4.0. This is the largest data and cover all scenarios that there exist. This is the largest data set available. So first we will describe the format of this data set, then talk about feature selection, test, train, validation, data set creation, and at the end of this data processing part we will talk about labeling process. Backbase data set consists of daily snapshots that contains date, serial number, model, and capacity of drive, information if this drive failed or not, marked with 0 for healthy and 1 if this is the last day that drive was operational before failing. And the most important, it contains the self-monitoring and analysis and reporting technology attributes that describes the behavioral drive. It contains raw values and normalized values. Normalized values are normalized by each vendor. In our experiments, we used only raw values in order to avoid losing some valuable information. We used attributes that are usually used in literature, like read error rate, that is frequency of errors during the read operation, spin up time, that is time required spindle to spin up to operational speed, start stop count, raw value codes the actual number of spin up spin down cycles, relocated sector count, the number of the unused spare sectors when encountering a read-write check error, a device maps a bad sector to a healthy one taken from the special reserve pool. Power on hours count, the raw value shows the actual power on time, usually in hours. Power cycle count, the raw value holds the actual number of power cycles. And at the end, temperature monitored by sensor somewhere inside the drive. Raw value typically holds the actual temperature in its rightmost two digits, represented in hexadecimal format. Regarding the dataset creation, we generate the testing dataset by selecting 30 healthy and 30 failed drives from each year at random. Then the remaining data is divided into training and validation dataset in proportion of 70 and 30% respectively. We modeled the failure process by a sequence of current day smart attributes and previous day smart attributes. We adopted sequence length of 30 days as it estimated that it is long enough to model process of disk failure. Labeling process, we selected the window of 30 days, and then for each window we checked in the backbase dataset if it is marked as failed on disk is marked as failed or not. If it marked as failed, then we put the label for all of these days as soon to fail drives, and in contrary we consider that drive is healthy. This reduces a little bit of class imbalance impact. Regarding prediction models, we consider both recurrent neural networks and convolutional neural networks, as well as combination. We consider long short-term memory as representative of recurrent neural networks because of their good property regarding vanishing gradient. Then combination of CNN and LSTM. ResNet specific architecture of convolutional neural network that is showed a good performance in time series classification domain. And lastly, we considered a simple CNN model that we developed in order to see if less complex models can predict soon to fail drives. LSTM neural network model consists of 4 LSTM layers and 1 dense layer, while CNN LSTM model consists of 1 convolutional layer, 1 max pooling layer, and 1 flatten layer that prepares data for 2 LSTM layers, and at the end 1 dense layer that perform classification of drives as soon to fail or healthy drives. This architecture already used in practice and in literature and gave the good results. Then we use ResNet architecture with 3 residual blocks and 1 average pooling, and then the dense layer for classification. The residual block used is described on the B section of this picture. Then our simple CNN model consists of 2 convolutional layers, 2 max pooling layers, and 1 dense layer at the end. Regarding training process, we couldn't address all challenges described in the introduction, but we focused mostly on dealing with large amounts of data, big data problem, and dealing with class imbalance. Many papers many papers address big data problem for different application, but usually this is done for some implementation by training batch by batch, chunk by chunk of data. However, in our application predicting of soon-to-fail drives, this is not explored in details, and there are no clear guidance how data should be combined in each batch. So we examined two ways: data to form batch for data collected from a single drive, and combination of data for failed and healthy drives. Regarding class imbalance, in the case where batch is formed from the data collected for a single drive, we apply both undersampling and cost-sensitive learning methods. On the other hand, in case when batch is formed from both healthy and failed drives data, we didn't use undersampling to avoid losing some important information. We want to support learning of differences between healthy and soon-to-fail operating characteristics in the same batch with as many examples. In addition, we try advanced methods to fight with class imbalance in machine learning models with sequential inputs that are developed recently in time series classification domain. This method dynamically adjust cost weights in the learning process to class imbalance ratio in each batch instead of to global class imbalance ratio used in the first case. Experimental results are divided and created by 2 series of experiments. One series of experiments are done in order to compare different ways to generate data in training batches. The other experiment series is done to see performance of advanced class imbalance technique developed for time series, which I talked about a few moments ago. On this slide, a comparison of different ways to generate data in training batches is shown. We optimize model to achieve the best F1 measure as possible. You can see in the first case, when batches are formed from one disk data, the best model is simple CNN model. On the other case, when batches are formed from mixture of failed and non-failed drives, the best models are LSTM and CNN LSTM models, and they have better F1 measure performance in the first case when batch is formed from one disk data. So we suggest that it's better to mix the data from in batches. You should mix the data from failed and non-failed drives. CNN, because they have the same performance, it is clear that features we selected for training are good, because CNN cannot learn a better representation that will improve the classification of drives. If we consider the performance of models when we are dynamically adjust weights or costs in training process, considering class imbalance at each batch level, we can see that we have a drop and F1 measure performance. The possible reason for that is that global class imbalance ratio incorporates information about annual failure rates of drives in training process, but when we used dynamic adjustments of this class weights according to the mixture of at the batch level, then this information are losing. So our conclusions are that we really propose the detection system that is designed to overcome challenges that arise from data characteristic in data characteristics for training models for training prediction models to predict soon to fail drives. The main focus was on big data and class imbalance application. It is experimentally shown that LSTM neural network trained in batch by batch manner, where each batch are from both information about healthy and failed drives, is capable to recognize 88% of drives that are soon to fail condition. But however, this comes at the price of 43% of false alarms. Thus, further research is needed to improve prediction precision. One possible way is not to optimize F measure, but to optimize prediction precision and to see how good recall this will offer. Thank you for your attention.
Good day, ladies and gentlemen. Let me please introduce myself. My name is Patrick Schwab, and today I would like to present the intention behind our article, the utilization of progressive methods in the manufacture and maintenance of aircraft components. It is a short content of my presentation. We'll start with the introduction and general properties, then we will go through the materials in aviation and the requirements on them. Then we will talk about potential of progressive methods in aerospace industry, and finally conclusion. Let's start with the introduction. The aerospace industry uses a wide range of materials, from metallic materials to plastics, ceramics, and composites. And when building aircraft components, the optimal properties of the material must be carefully chosen. Each material must meet all not only functional but also financial and technological requirements. And the functional properties of materials that are used in aircraft construction must be as best as possible. And the materials are chosen mainly with the lowest possible specific weight, but at the same time with a high specific strength, and so they will be able to extend the overall life cycle and lifetime of the component. And the strength characteristics of the materials are usually chosen regarding the safety as much as possible, so to the maximum possible limit. However, this means that the strength values of said material must be sufficiently reliable, and the fatigue strength properties must also not be significantly reduced during long-term operation, and this is also associated with the overall lifetime of the aircraft. So now something about general properties. These are like the most important ones. So the main interest in the construction and maintenance of aircraft are the general properties of metals, materials and their alloys, such as hardness, the malleability, flexibility, strength, density, brittleness, meltability, conductivity, contraction and expansion. There are multiple ones. So hardness refers to the ability of material to withstand wear, penetration, cutting, or permanent deformation. Hardness can be increased by cold working metals, in the case of steel and some aluminum alloys by heat treatment. The components are often made of metals in their soft state, then heat treated to strengthen them, therefore preserving their final shape. Hardness and strength are closely related properties of metals. One of the most important properties of materials is strength. Strength is the ability of material to resist deformation. It is also the property of material to withstand impact without permanent deformation, without taking much damage. And the types of loads or shocks to which the material is exposed affects its strength. Then density is the weight per unit volume of material. This is also called specific weight. And when working with aircraft, the specific weight of material per cubic inch is preferred because this information can be used to determine the weight of the part prior to actual production. Density is an important factor in selecting the material to use in the design of a part to maintain the correct weight and balance of the aircraft. Metal which can be forged, rolled, or pressed into various shapes without cracking, breaking, or leaving any other harmful phenomenon is considered to be malleable. Flexibility is a property that allows the metal to return to its original size and shape when the force that caused the shape to change is removed. This feature is extremely valuable because it would be highly undesirable to have a component that is permanently deformed after the load is removed. Each metal has a point known as the limit of elasticity, and it cannot be loaded above this value, as it would cause permanent failure, permanent damage. In the construction of an aircraft, the components and parts are designed so that their maximum load to which they are subjected does not exceed values above their limits of elasticity. And meltability is the ability of metal to become liquid when heat is applied. And conductivity is a property that allows the metal to transfer heat or electricity. Thermal conductivity of a material is especially important in welding because it regulates the amount of heat that will be needed for proper melting. Conductivity of the metal to some extent determines the type of preparation which should be used to control expansion and contraction of the material. Materials in aviation. Many materials have been used in the history of aviation. In the beginning, mainly wood and fabric. Then later aluminium and multiple specific alloys were used. Alloys have a general representation in aviation to this day, as the alloys have required properties for the individual elements of the aircraft structure and construction in general. Over the years, and with the gradual development in aviation and aircraft construction, development has reached an important milestone: composite materials. Composite materials are modern materials, and the development of which began not so long ago. Even though their construction itself was observed, to be honest, from nature. Among composite materials with fibrous structure, we also include wood for its structure, also bamboo, grass blades, or the structure of animal bones. Composite materials are divided according to their type of reinforced component into composites that are reinforced with fibers or short fibers, so-called whiskers, and composites that are reinforced with dispersion, for example, metal oxides, and composites produced by controlled crystallization. Composites are further divided according to the type of matrix into composites with organic matrix, or polymers, ceramic, and metal. The last group consists of composites formed by a silicate matrix, for example, prestressed concrete or reinforced concrete, which are often used in construction. Depending on these resulting properties, composites are divided into composites that have high mechanical properties and composites that have special physical-chemical properties. Imported composite is Aral. It was the first fiber metal laminate used in aerospace. It was invented in 1978 in laboratories designed for material research in Netherlands. After considering the use of the newly formed composite materials, it was found after evaluations in flight simulation that by using Aral, the weight of aircraft can be reduced by up to 30% and their service life can be significantly extended. Due to its excellent fatigue resistance, Aral began to be used mainly on the lower parts of the wings for covers and rear rudders. But Aral cannot be made with fibers that are oriented in multiple directions. These problems were fundamental as they limited the laminate properties and thus its use in places where it is subjected to high stresses. Instead of aramid fibers, glass fibers were first used and applied in laminate in 1990s. And this laminate was called glare, and so many negative aspects, many problems that Aral had. In addition, it surpassed its many mechanical properties. So glare could finally be processed with the orientation of the fibers in multiple directions. This allowed the designers to use this laminate in much larger proportions of structures and aircraft constructions. In the picture, we can see Boeing 747. As you can see, it consists by 50% of composite. So requirements on materials in aerospace industry, there are many of them. You can see the most valuable, most important ones. And there are certain basic requirements for materials. These requirements, due to their high energy consumption, are high strength, at low weight, and resistant to stress. Also resistant to atmospheric conditions, and to permanent damage. These conditions include the atmospheric conditions include rain, hail, icing, atmospheric discharges, heat stress, sunlight, or for example also bursts are considered atmospheric conditions. In particular, the strength requirements are formulated by aeronautical regulations to minimize the likelihood of failures due to the lower value of the strength characteristics of the material than those taken into account in the, for example, design calculations. So load resistance, if either dynamic or static tests are used to demonstrate compliance with the airworthiness regulations, factors suitable for repair shall be used to correct the test results depending on the construction materials that are used that are tested. Suitability as well as durability of the materials used for the production of components, the failure of which may adversely affect safety, overall safety, is assessed on the basis of demonstrable tests and experience. This corresponds to the approved standards which are consistently applied. It is the technical regulations of military and civil aviation specifications that ensure that the actual load-bearing characteristics of the structure as well as other properties will be in accordance with the design data from the pre-construction calculations and simulations. So in addition, all probable environmental influences such as humidity or temperature that can be expected when operating aircraft must be taken into consideration, must be considered. The strength characteristic of the material must be documented by the required quantity and in the required quality of the performed test processed by means of statistical methods. Important property in the requirement: fire resistance. Flammable liquids and vapors must be defined and identified in detail from each area of their possible escape. Parts of the, for example, engine installation, the basic control system, and also parts of the primary structure, which occur in area where leakage of liquids is possible, and these liquids are flammable, or in areas which are adjacent and could therefore be exposed to direct fire. These areas must be manufactured from fire-resistant construction material or must be shaded in such way so they will be able to withstand fire and its effect. Now, the potential of progressive methods in aerospace industry. In a matter of construction, when regarding the construction and like aviation industry, in terms of construction of the aircraft, additive manufacturing (AM) can be defined as the exact opposite of traditional machines to produce parts or components. As you can see in the picture, case A is called subtractive manufacturing, when you have the whole material and then you manufacture the part or desired shape from that material, which produce much more waste than additive manufacturing. Additive manufacturing is, for example, 3D printing, but in nowadays conditions, which are greatly increased in the overall characteristics and properties of the material. So several additive manufacturing techniques have been introduced in recent years. And what makes AM interesting is that thanks to the maximum freedom in shaping, it is possible to create even extremely complex shapes and complex structures based on thin lattice structures can achieve high structural efficiency, where the whole material exhibits similar stress values at all points. Industry 4.0 concept introduces several key assistive technologies that could change aircraft maintenance. One of them is also augmented reality. Technologies such as additive manufacturing and augmented reality, which have been improved by the industry 4.0 revolution, will be a key element in the aviation maintenance strategies of the future. It should be noted that the aircrafts, helicopters, and other automatic machines can be composed of million parts, and they require complicated maintenance. which often require specific equipment and tools needed for assembly or disassembly. In this place, virtual reality can be useful in these areas of advanced engineering, where it is possible to undergo virtual training and practice precise procedures in various situations that reduce the occurrence of human errors due to incorrect placement and use of incorrect type or parts. Realistic 3D CAD model of the part that needs to be maintained can be projected into video stream where an external organization such as technician specializing in these types of failures can also comment on the problem. Training in virtual reality where the scenario moves forward only if the set conditions are met can help reduce the risk of skipping a phase or step in a maintenance process, which can really very easily occur in a real situation. Additive manufacturing can be also combined with AR or VR. In fact, virtual reality can be useful for creating an extended maintenance manual and illustrated parts catalogs, where the appearance of the part being repaired is designed by the operator intuitively based on the actual aircraft. This is especially true for VR and AR-based manuals, where assembly and disassembly tasks are presented to operators through a combination of CAD models, symbols that suggest manual operations, virtual panels where operations can be controlled, and communicate with technology through gesture tracking. Additive manufacturing could also be used for remote maintenance, where virtual animations could be prepared in real time to support and manage complex procedures through centralized maintenance centers, and if necessary, the captured image will be projected to remote operator and to remote devices. This could overcome one of the problems that currently limits the use of VR in industry, and it's the time needed to prepare animations. In the case of modern transport, aircraft is made of many parts. It should be noted that the implementation of the animated virtual sequences for each possible maintenance operation would be time consuming, but in a greater picture it will be very useful and we can say efficient. So in conclusion, the ability of augmented reality and virtual reality to combine virtual and real parts allows you to simulate complex scenarios without the need of inaccessible parts. Overall, the impact of virtual reality of aircraft maintenance can be really big, really huge, especially in dealing with complex operations that cannot be clearly explained in traditional paper manuals. In addition, the documentation must be in operation for several decades, with the average service life of commercial aircraft ranging from 20 to 40 years. Virtual reality can help to update maintenance procedures for instructions based on text or real-time maintenance documents. However, implementing all commercial aircraft maintenance tasks in virtual reality can be and is a complex task. Nowadays, the most realistic solution is to design the initial implementation of only the most critical, the most crucial and demanding maintenance operations in the VR. On the integration of short-term maintenance preparation environments and enrich scenes into the virtual reality system using CAD modeling, using CAD modeling could reduce the time required to implement entire maintenance manual in virtual environments in the near future. Virtual reality can be used in aviation to support maintenance in several ways. Illustrated augmented reality or virtual reality based parts catalogs, virtual environment based maintenance manuals, remote maintenance software tools, VR support assembly and disassembly operations. These are just one of the many solutions this technology provides and can provide that can benefit from implementation. And eventually, this method to aviation industry. This technology, the virtual reality, can be useful for bridging the gap between traditional text manual training, where simplified two-dimensional sketches represent complex components and the reality where complex three-dimensional shapes must be detected and assembled, often hidden under other components and assembled or disassembled using advanced technology tools. These are just like main problems that can be focused on in the future. So that will be all from my presentation. Thank you for your attention. I hope you enjoyed it. If in case of any questions, feel free to ask or contact me.
Hello everyone, and welcome to the presentation for the paper titled End Users and Industry 4.0 Systems Cyber Resilience from Cross-Site Scripting Attacks. The authors of this paper are Ivan Cvitic, Dragan Perakovic, Siniša Husnjak, and Dominik Sever. On today's presentation agenda, we have firstly introduction, then related research that inspired this paper. In the third section, I'll say a few words about cross-site scripting attacks through analysis and classification of cross-site scripting attacks. Then I'll present you a simulation that was conducted for the purpose of this paper in section Cross-site scripting attack simulation using AB framework. After that, I'll talk about synthesis of results and the proposal of protection guidelines through methods that were tested in this research. And in the end, of course, a conclusion. As we are all aware, there is an increasing number of companies that provide their services over the internet. Of course, that is a good thing, but problem occurs when there is increasing number of cyber attacks that come alongside. So any user connected to the internet can be the target of a cyber attack. Since Industry 4.0 is characterized by high usage of information and communication technologies and concepts such as Internet of Things, cyber threats can compromise industrial management system in Industry 4.0 environments. Therefore, companies and organizations can suffer big damage by cyber attacks. In this paper, we focused on cross-site scripting attacks as one of the most common types of cyber attacks. Regarding related search, we have three here. The first one titled Preventing Persistent Cross-Site Scripting Attacked by Applying Pattern Filtering Approach. So authors suggest defense method by applying filtering based on defined samples. It is suggested to apply filtering on event handlers, uniform resource identifiers, or shortly URI, unsafe keywords, special characters, and so on. The second one, titled XSSDS, Server-Side Detection of Cross-Site Scripting Attacks, suggests detecting reflected cross-site scripting can be done by matching input and output data and checking for similarity. In other words, if an attacker injects a malicious script an HTTP request, that script should be fully contained in HTTP response. Therefore, detecting cross-site scripting can be done by matching input and output data and checking for similarity. For stored cross-site scripting, authors suggest analyzer with list of known scripts. So if some new unknown script appears, it is most likely an cross-site scripting. The third one is mitigating cross-site scripting attacks using a reverse proxy. So it is a server-side solution that works as a reverse proxy. All data that is returned back to the user must pass through a reverse proxy with implemented detector. So if a detector detects an unknown script sent to the user, the response is blocked. Regarding cross-site scripting, it is a type of cyber attack that is performed when an attacker implements a malicious code or script into a seemingly harmless website or web application. Most used programming language is JavaScript because it is a language used for web development and it is being executed in the web browser. So malicious script is also executed in the attacked user's web browser. The cross-site scripting is classified in three classes. The first one, called stored or non-persistent cross-site scripting, where the attacker's malicious script is stored in the web page database. So any website visitor can be a victim of an attack. Most vulnerable types of websites are forums, blogs, social networks, and so on. Basically, the types of sites that have input fields like comments and so on, where attacker can implement his script. The second type is reflected or non-persistent cross-site scripting. In this type, malicious script is not stored on the web server or database, and therefore it is mostly used for a targeted attacks because attacker can craft a link with his malicious code and send it directly to a targeted victim. And the third type is document object model based cross-site scripting. It changes DOM-based environment in the victim's browser. So response does not contain an attacker's payload. Therefore, it can be hard to detect with server-side detectors because the payload manifests itself only on the side of the user's browser. Regarding trends in cross-site scripting attacks, here we can see two charts with most common cyber attacks in year 2017 and 2018, and the data is provided by organization PT Security. As it can be seen, the cross-site scripting is always in top 3 of the most common types of attacks. There can be some variations between the top 3, but cross-site scripting is always at the very peak. For newer data, we have this chart for the year 2020 from the company EdgeScan, and it shows the most common critical vulnerabilities in 2020. As it can be seen, cross-site scripting is again at the very top of the chart. From this and the previous slide, it can be concluded how much of a threat cross-site scripting is. Now we can continue to the simulation section, and here can be seen a simple diagram that depicts the simulation setup. The attacker is a computer with Kali Linux operating system and the BIF framework installed on it. For the purpose of the simulation, the simple HTML page was created and a Apache server started so the page can be accessible on the local network. In the HTML page, the hook JavaScript script was implemented. The script was provided from the BIF framework, and therefore when opening the page on the other computer or the attacked side, the browser was connected to the BIF framework. Here we can see the BIF interface and connected browser in the top left corner. We can read its IP address. Immediately after connecting, some relevant information can be seen, like browser the attacked user is using. In this case, it says Chrome. The browser's engine, in this case, it is Blink, so yeah, that is good. The CPU architecture, even the graphics card that is used on the attacked PC. In the simulation, we simulated 5 different attacks that are available in the BIF framework. The first one, pretty theft, in the form of a Facebook login pop-up. Then the Google phishing, detect the social networks, get page HTML, and redirecting the browser to the malicious payload. The last one is the most complicated one, and it is the most malicious one. Here we can see the result of 2 of the attacks. So after user enters its credentials in the Facebook pop-up window, his email and password is shown in the BIF interface. So the attacker can log in into his Facebook, for example. And the below one picture is a result of fetching open sessions. As you can see, it returns if user is or is not logged in some of the social networks or services. This can be used in combination with other attacks like previous Facebook pop-up window or something like that. Google phishing has a similar result as pretty theft. It opens a Gmail login page and sends an input to the BIF interface. And after executing get page HTML, attacker can see a HTML code of the web page. The last attack was done in combination with Metasploit framework. To be more precise, its model MSF Venom was used to create a malicious payload. So the payload needs to be created and sent to the attacked computer to gain remote access to the computer. In the below picture, you can see the interface for redirecting the browser. Here the payload is named setup.exe because it could be name misleading in the real life situation. The attacked user downloads the malicious payload and executes it, and through a listener active on the attacker side, attacker can have a complete remote access to victim's computer. He can navigate through directories, download files from his computer, send files to his computer, change files, for example, change some text documents that could be imported for him, execute commands through command line, and so on. All in all, a lot of very dangerous actions. Here on the picture you can see the result of ls command that lists the files and folders in the documents on the remote computer. For the synthesis of the results, here in this table you see again those 5 attacks, and Pretty Theft and Google Phishing both pass user credentials to the attacker. Therefore, attacker can have access to the login information. Also, there is possible compromise of other services as well if user uses the same credentials for other services or networks, and that is a very common thing today. With the tech social networks, information is visible in the interface if the user is logged into one of the offered networks. That information can be used for further attacks. Results of getPage.html was the HTML code of the open page. That information can be used in example for planning of further implementations of malicious code in the website or something like that. And the last one, redirecting the browser to the malicious payload, compromised the victim's computer. We were able to fetch files, send files, execute commands, and so on. In this table we have 4 defense methods that were tested. The first one is JavaScript blocking. It is the most simple one. It is available in most of the web browsers. It blocks execution of JavaScript when opening the page, but the problem is that it blocks all of the JavaScript, also the good ones and the ones important for the work of the website. So some pages can be not usable anymore. The second one, uMatrix, proved to be a very good solution. It is implemented as a plugin in web browser and is pretty easy to use. The downside is that it could possibly give an incorrect verdict to the risk, thus blocking something that shouldn't be blocked. But that happens very rarely. In this simulation, the malicious script from Beef was blocked, and Beef cookie was seen in the uMatrix log. The third one, Xpeer, is a tool that needs to be installed on Linux operating system. It detects vulnerabilities in the provided websites. It could be complicated to use for everyday user, but could be a good tool for web developers to test their websites. The last one is burpsuit. It can be installed on Linux, Windows, Mac, and it is quite a powerful tool. The browser needs to be set up to send data through burpsuit, and that way it detects a malicious script. In this simulation, the script was also blocked, and therefore the browser was not connected, and further attacks could not be conducted. And for conclusion, we can say that cross-site scripting attacks are one of the most common types of cyber attacks, and there are a large number of different end consequences that are possible for the attacked user. Therefore, the user must take certain measures to ensure the protection of his computer and his data. Between the tested methods, U-Matrix stands out with a good ratio of simplicity and functionality for the end user and for everyday use. And the Xpeer stands out as a good solution for developers to detect vulnerabilities to cross-site scripting attacks. And thank you for your attention.
Ladies and gentlemen, let me introduce the topic education and its role in the risk management in the context of Industry 4.0. My name is Aleš Pernatík. I'm working in Technical University of Ostrava in Faculty of Safety Engineering, and I would like to thank of my co-authors of this presentation, of Eai Mms and Vendula Laciok, for your cooperation. Let me introduce this topic. I think the Industry 4.0 brings technical and social development to this current world, and we have new challenges in various branches, mainly in education, safety and quality. But you can see in this picture that Industry 4.0 will involve many other branches. Our impact of education of Industry 4.0 will be also very important. First of all, it will be interdisciplinary, and technical skills for students will be necessary, but also communication and direct work with robotic devices, with robots, and also students will need to use this digital literature. Therefore, the consequences of new work conditions under this umbrella of Industry 4.0 will arrive new risk, new emerging risks. So one from this risk is maybe stress, maybe ability to concentrate. The most common cause of accidents of the work is incorrect estimated risks and also insufficient training of experts in this risk management. Therefore, ensure the best training of experts in this risk management is very important for the partners from industry. And therefore, we prepare some individual survey. It was survey for industrial company, for our safety experts, our partners from our university, and to discuss some questions. The method used was statistical technique of this questionnaire survey, and we used the Pearson's Q-squared test. I would like to present some example of hypothesis. First example of hypothesis is employers prefer graduates from Czech Technical University in Prague instead of VSB Technical University in Ostrava. You can see from the graph that the answer of our industrial partners was not so big difference, so we can say that the hypothesis is not confirmed in this level of significance. Second hypothesis, if employers do not care at which school their future employees studies. You can see that the answer was not care, so we can see that this hypothesis is confirmed. The type of university is not so big problem. But third hypothesis, if after graduating from university, students' knowledge is insufficient for needs of employers, was very important. The answer from industry was the knowledges are sufficient. So again, the hypothesis was not confirmed. The final example of this hypothesis, if the employers are not cooperate with universities, if they have some interest to in the future to cooperate for kind of form of students internships and other practice work and so on, and we can see that this future cooperation is welcomed of the most of the answer. So still the hypothesis was not confirmed. So we are very happy that industry is welcomed in cooperation with students from universities. I would like to conclude this part of presentation of hypothesis. The recommendation for the cooperation of universities with industrial companies during the studies is by the use the practical work is very welcomed, very recommended, not to wait for finish of all studies of students. So the cover this industrial practice into the study is very welcomed. Graduates' knowledge of new technologies needs to be increased because there is new challenges from Industrial 4.0, so we need new challenges. And study program must be aimed for acquiring skills from industry, and mostly also in the information processing part, because the information sources are very important. Some general recommendation from Industry 4.0. One from this recommendation is the public awareness and involvement in the risk management process. We can see that public must be involved in the role of active participant, must be in contact with industrial companies. And the recommendation for universities, the university must be based on 3 pillars, and the pillars are education, research, and also cooperation with practice, with cooperation with industrial companies. So, conclusion of this short presentation. In the following years, several new work areas will emerge in companies, and the big difference is that simple work manipulation will be performed by a robot. Therefore, the new methods and context must be integrated into education process. It means that principles from Industry 4.0 must be integrated into the study programs for students. And without highly skilled workforce, without employees, it will be not possible to gain the competitive advantage in this time of this globalized economy. So thank you for your attention. I would like also thanks our Technological Agency of Czech Republic for obtaining this project, and thank you very much.
Ladies and gentlemen, my name is Martin Miško Pavlik and I am a PhD candidate at Technical University of Košice at Faculty of Manufacturing Technologies with seat in Prešov. I am pleased and honored to participate once again in this online conference. I would like to introduce you the article Application of Vernier Measurement System as a Smart Element in Physics Educational Process. This article was prepared for this conference in cooperation with Associate Professor Orchakova, Professor Jurko, and my colleague Mr. Kaščák. This presentation consists of 5 chapters: the introduction, in which we approach the aim of the article, the application of new Vernier measurement and educational system, and their implementation in the process of education in physics at the Faculty of Manufacturing Technologies. The second part consists of the description of Vernier's DTS and GDX measurement system that have been used in the physics education. The third and the fourth chapter deal with the description of the statistical processing of the data obtained from the experiment, in which first-year bachelor students completed an entry questionnaire at the beginning of the semester and an output questionnaire at the end of the semester to demonstrate positive effects of application of the Vernier measurement and education support system. The presented article focused on the analysis and statistical evaluation of the educational process in which modern information technologies were implemented into the educational process of physics and exercises in physics courses intended for full-time and external students in the first year of the bachelor studies at the Technical University of Košice at the Faculty of Manufacturing Technologies with a seat in Prešov. The main thesis is the renewal of the educational process of physics by using the Vernier measuring systems, which is a complex solution for the school laboratory and enables practical teaching with the latest computer and mobile communication devices. Based on students' results from the questionnaires, the faculty plans to purchase more Vernier measurement systems, better integrate students into the educational process of physics. Based on students' responses, the teacher can focus on area that the students are having the most difficult with. The output questionnaire at the end of the semester was intended to show whether the innovation of the laboratory with the new measuring equipment increases the interest in the physics studies, strengthens the knowledge of the physics, and contributes to the improvement of physics teaching at the Faculty of Manufacturing Technologies. The education process of physics was innovated by the mentioned Vernier measurement system, which provides a complete solution for school laboratories and allows a practical teaching with the latest computer and mobile communication devices. The main reason for application of this measuring system is often the problem that students do not see a practical significance and application of physics in real life, and this needs to be changed. It should not be forgotten that organizing an experimental lesson for students requires proper training by the teacher as well. Do not mention the time intensity, material equipment of the school, insufficient number of tools, and poor working environment. Nowadays, engineering practice requires highly skilled professionals who have a comprehensive understanding of the state of modern engineering and can work with the latest technologies. That is the reason why a modern applied physics laboratory has been set up at the Laboratory of Applied Physics in this article, which use the latest information and education technologies as well as Vernier measurement systems. The first of the used measurement system is a dynamic wheelchair DTS with a wireless connection to study the motion, flexible collisions of the carriages and the laws of the conservation and momentum and energy. Using a force sensor and a set of buffers, it's possible to study the relationship between momentum and impulse. Next applied device is a GDX measurement system to study damping force and its relationship with angular velocity, weight, and turning radius. The rotating arm with two moving trellis and the cable mechanism is mounted on a stable frame. We can also study rotational dynamics by calculating the forces necessary to keep matter in a circular motion, or Newton's laws involving torque and rotational motion. This system is characterized by very simple and intuitive operation and a wide range of different measurement sensors and a reliable software solution. The result of laboratory measurements can be evaluated not only on computers but also on tablets or smartphones. The experimental part of this article consists in the statistical processing of the students' results in the first year of bachelor study at the beginning of the semester with the Vernier measurement system and after its application in the educational process. The statistical analysis itself consisted of processing two questionnaires. The entry questionnaire was completed at the beginning of the semester when the student had no experiments in using the Vernier measurement system and only had knowledge from the high school. Compared to the entry questionnaire, a second output questionnaire was also completed, after which we evaluated students' score results. Based on the students' responses to each question in the questionnaire, the teacher can then identify the area with which the students have the greatest problem and exploit the problem using individual Vernier measurement systems. The questionnaires consisted of 6 questions from different areas of elementary physics. A total of 87 students, male and female students, participated in this experiment. The first part of the descriptive statistic was to create a table in which we determined the absolute impedance. In the next column, we reported the relative impedance, cumulative impedance, and the cumulative relative impedance. These students were divided by the type of the high school they graduated from, namely the gymnasium type of school, vocational school, or other type of the educational institution. As a first step in the statistical analysis, we started with a comparison of the individual test results. The results of the input and output tests were divided in a simple breakdown according to the number of correct answers of each student from 1 to 6, representing the value of the x. Analysis of the table showed that the highest number of responses ranged from 5 to 49 students, representing 56% of the total number of responses. Overall, 68% of the students had 5 correct answers and only 32% of the students scored full marks. Compared to the entry test from the table, there was an improvement in the students' overall score when the highest number of correct responses was 6, with the 49 students representing 56% of the total responses, which is a 24% improvement compared to the entry questionnaire. The percentage of the students who gave up to 5 correct answers dropped to 44%, which is a 20% less than the entrance questionnaire. One of the negative phenomena that occurred in the output questionnaire was also the occurrence of the lower interval responses categories such as 1, 2, or 3 responses, which did not occur in the entrance test, but their number has very little impact on the total number of responses. After division the respondents according to a high school they graduated, the first group was the graduates of vocational type of high schools. The sample included 55 respondents who were not yet divided according to a number of years of physics completed. It can be seen from figure that the biggest problem for the students in the entry questionnaire was question 5, which only 63% of the respondents answered correctly, and they performed best in the question 1 when they achieved a success rate of 100%. Compared to the entry questionnaire, there was an overall improvement in student score when using the Vernier educational measurement system from 86% to 88%. The second group of respondents were students who graduated from a gymnasium type of the high school. The number of respondents this time was 13. In the case of an entry questionnaire of the students who graduate from a gymnasium secondary school, we can see from a figure that the lowest percentage of a successful answer was for question 6 and 4, only 61% and 69%. Overall, the average percentage pass rate of the students from an entrance questionnaire was 85.9%. Comparing the results of the entry and output questionnaire of the gymnasium student sample, we can see an improvement in the question 2, 4, and 6, and a deterioration in the 3 and 5. The overall success rate was an average level of 91%, which corresponds to an improvement of 5%. For this category of students from another type of educational institution, the table shows that these samples scored the lowest or worst results after application of Werner's system. Students' average percentage success was 87.7 on the entry questionnaire and only 85.9% on output questionnaire. Students had the most problem on question 4, and the highest number of correct answers were on question 1. The distance learning factor due to COVID-19 pandemic must also be factored into the questionnaire results, which was reflected in some of the poorer responses on the output questionnaire, such as question 1 and 6. In the overall comparison of the results from the entry and output questionnaire, it can be seen that there was an improvement in the results, which is confirmed by the average value percentage of the questionnaire results, with the entry questionnaire showing 86.8% and the output questionnaire showing an improvement 87.9%. The highest improvement occurred in the question 4, where there was an improvement from 65.2% to 87.3%. After dividing the respondents by completed years of the physics in high school, we can see that there was an improvement in score in almost every category. For students who had only 1 year of physics, mostly students from other schools, the improvement in scores ranged from 87% to 89%. In the 2-year category, the improvement was from 84.7% to 85.4%, mostly students from vocational type of high school. The third category was the students with the 3 finished years of physics in high school. In this single category, the results deteriorate from 83.3% to 80.9%, with the largest number of students being gymnasists. The final category was the 3+ years completed physics, where the improvement was from 88.2% to 90.2%. The composition of the students was mainly from a gymnasium type of school, and the minority proportion was from a vocational school. Finally, the groups and Dixon square outlier detection test was performed, in which we determined the distance between the lowest and highest measurement responses to determine if any of responses were not too demanding. Using these methods, we can determine if the questionnaire results contain a value that proves to be an anomaly compared to other ones. Through such analysis, more challenging questions can be defined based on the number of correct answers in a questionnaire. In the first step, we rank the samples by size in both questionnaires into the non-decreasing sequence. The measurement values for the input questionnaires were 57, 72, 73, 81, 85, and for the output questionnaire 74, 75, 76, 78, and 81 correct answers. The first questionnaire is to determine whether the values of 57 and 85 are outliers. The test results showed that none of the values were too far off, which was supported by the box plot, so all the questions were appropriate. The output questionnaire results at the end of the semester confirmed to us that the innovation of the laboratory with a given measurement system increased the interest in the study of physics, strengthened the knowledge of the physics, and contribute to the improvement of the education process of physics at the Faculty of Manufacturing Technologies. In further research on the application of linear measurement systems, we would like to show the advantages of using this system not only for physics classes, but also for mechanics, statistics education process, and more. In the end, I would like to thank you for your attention and wish you all the best.
Good day. Let me introduce myself to you at the beginning. My name is Miriama, and I work at the Technical University in Košice. Today I will present the results of our research titled Using Quality Management Tools to Analyze the Error Rate in the Production Process. The quality of production is currently a decisive factor in business. It is the basis of success in the market, and it is also crucial to the overall prosperity of the producing organization. This article examines the detection of the most common errors and their causes in the production process of printed circuit boards. Basic quality management tools were used for analysis and evaluation, namely FMEA, Pareto chart, and Ishikawa diagram. Through them, we identified not only problem points in the production process, but also measures that the organization subsequently introduced into the production process. The company in which error analysis was carried out in the production process using quality management tools is a manufacturer of industrial electronics. It has been operating in Slovakia since 2000. The organization has an integrated management system and holds certificates that demonstrate compliance with the requirements of the ISO 9001:2015 standards. The basis of production is 6 assembly lines, where the production of printed circuit boards takes place from their installation, testing, and final assembly to the delivery of the finished product to the customer. One of the production lines of this company analyzed in this paper is semi-automatic with manual production predominating. This is the finalization line on which PCB production is completed. There are 11 operators working on the production line. See Figure 1. They have workflows that describe individual work operations with the names and component labels for specific PCB models. Depending on the model currently being produced, operators choose a workflow and check the individual components. 3 selected quality management tools are used to analyze the error rate of a particular production process: FMEA, Pareto chart, and Ishikawa diagram. At first, failure mode and effects analysis is one of the basic tools applied within ISO 9000 standards. The aim of FMEA is to analyze potential errors in a particular system over a selected period of the service life of the system, so that corrective measures can be taken to reduce the risk that the emergence of errors entails. According to Stamatis, an FMEA system can be achieved using a series of steps that include conceptual design, detailed design, and development, test, and evaluation. Secondly, Pareto analysis is one of the most effective quality management tools, which makes it possible to separate the root causes of a particular problem from the minor ones, thus showing the direction in which efforts to ensure quality assurance in the process need to be focused in order to remedy its shortcomings. The Pareto chart was first used in quality management by Joseph Moses Uron. According to Douglas Montgomery, the Pareto chart does not automatically identify the most important defects, but only the most frequent. Thirdly, Kaoru Ishikawa developed a simple tool to identify possible causes of a problem, known as a cause and effect diagram, or a fishbone diagram. Very often a version of the diagram with the main categories of causes is used: people, material, machines, methods, and environment. The analysis and evaluation of the quality of the production process is divided into 4 parts. Analyzing the production process using the FMEA method. Evaluating the occurrence of errors using Pareto analysis and Pareto chart. Finding the main causes of the most common errors using the Ishikawa diagram. Proposing measures to eliminate the most significant errors. FMEA results. The aim of the analysis was to analyze the production process and to determine the occurrence of errors at the different stages of production. The main tool in the development of FMEA was brainstorming. The result was the determination of a risk priority number, which is expressed as the product of 3 indices: severity, frequency, detection, where each index can receive a score in a certain interval. In our case, the score is on a scale of 1 to 5, see Table 1. The resulting risk priority number value is between 1 to 25 points. FMEA pointed to some critical points in the production process. Based on the risk priority number index, a risk level was established. The mean level of risk has been identified at production stages such as material preparation, glue application, capacitor, filter, connector mounting. For risks exceeding a specified value of 15 points, include 4 functions of the process, see Table 2. For example, the installation of the fuse reached a risk level of 20 points. Cause of the failure: unwetted area when installed, resulting in malfunctioning PCBs. By supplementing pin tester, we will reduce the risk level to 10 points. FMEA pointed to some critical points in the production process. Measures to eliminate deficiencies were recommended for these production areas. The implementation of the measures has resulted in a significant reduction in the values of the risk priority number. Results of Pareto analysis. Data analysis was divided into 2 periods. In the 2019 year, in months, September and October, and in 2020, February and March. The errors observed, together with the degree of severity of the errors, are in Table 3. Error analysis focused on the production line system for hand-installed components on the printed circuit board, the final step of production. The degree of severity is expressed using a natural number between 1 and 10, with 10 being the most serious error. Figure 2 is a graph showing the occurrence of errors in the manual installation of components during the reference periods. A total of 1978 deficiencies were identified in the 2 reporting months of 2019. The most significant number is in the case of error 1, missing part, which accounted for almost 35% of the total number of noted errors. In the 2020 year, 1447 component planting defects were identified, representing a reduction of almost 27%. Again, the most significant number was error 1, missing part, which accounted for approximately 32% of the total number of noted errors in a given period. For evaluation using Pareto analysis, we chose the 75/25 criterion, under which it is recommended to monitor in more detail errors for which the cumulative relative number reaches a value equal to 75%. The results obtained show that the situation in terms of product quality has improved over a number of months. Absolute error rates, except for error 2, decreased significantly. In the case of error 3, the decrease is by up to 68%. An analysis of the production process showed that error 3 were mainly due to the cooler component, which has multiple connectors, is harder to install, and can get raised in the oven. For this reason, it was proposed to adjust the setting of the oven by changing the shape of the weights used to load the cooler before it enters the oven. The situation also improved with error 1, a decrease of almost 9%. In the case of error 2, the absolute number increased by almost 8% compared to the previous period. Therefore, for error 2, it was been proposed to add an in-circuit board tester control pin to check the length of the connectors. Adding this will extend the testing time, but will improve the quality of the supplied board. The Pareto chart shows that during the 2 months in 2019, 3 defects formed a vital group of causes of poor quality products: missing part, missing pin, and raised part. In total, these 3 errors accounted for up to 76% of all detected errors, see Figure 3. In 2020, the order of errors changed slightly. The vital group of causes consists of only 2 errors, missing pin and missing part, which represent up to 75% of all errors in the production process during the given period, see Figure 4. Results of Ishikawa diagram. The Ishikawa diagram, or fishbone diagram, is an appropriate tool for solving problems arising from the results of Pareto analysis. Under the chosen criterion, 75/25, it is recommended to address a vital group of causes of poor quality products in the next step of the evaluation of the quality of the production process. In the case of the monitored production process, these are errors, missing pin, and missing part. The basic subproducts for which measures have been proposed to eliminate error 1 or 2 error numbers are indicated in red. The cause most involved in the number of error 1 is the people category, where compliance with working procedures, necessary concentration, and length of training is crucial. See picture 5. The methods and machines category appear to be another problem. The basic subproducts for which measures have been proposed to eliminate error 2 are indicated in red. The frequency of error 2 was mainly affected by the method of packaging and handling during unpacking and transport. In the case of the machines category, the setting and maintenance of the tester, and also wear and tear of the control pin and the interval of its replacement and failure are significant causes. The category people mainly works experience, working discipline, focus on the work performed and adherence to the prescribed workflow. The proposed measures for the 3 most important main categories, people, machines, and methods, are summarized in Table 4. In the people category, we proposed these measures. Firstly, rewrite workflows into a more comprehensible and clearer form. Retrain operators and educate them about the internal rules of the organization. The second measure, inform operators about the number of errors caused by them and motivate them to work better. Thirdly, set up training rooms for newly recruited operators where they will undergo 2 weeks of skills training before starting work. The individual procedures for analyzing a given production process identified errors for which it was necessary to design and take measures to reduce or eliminate them entirely. Using the Risk Priority Index, FMEA has clearly highlighted the critical points in the production process for which the necessary measures have been proposed to prevent these errors. The Pareto analysis identified the causes of key errors in the working environment, the error 1 and 2. For better diagnosis of the problem, for each major category of causes, subcategories were determined, supplemented by other minor causes with their share of the observed error. In both cases, it was confirmed to us that the human factor had a significant influence on the number of these errors. Therefore, human resources need to be given at least as much attention as technical equipment, finance, and other production capacities. Currently, a lot of attention is paid to the quality of any product. In addition to increasing requirements for increased and accelerated production, this is due to the growth of customer requirements for the quality of the final products. Deficiencies and defects will always appear in the production process. Defining significant errors and their causes enables your organization to focus on reducing or eliminating them. Quality management methods play an important role in the analysis and evaluation of errors. Thank you very much for your attention.
Ladies and gentlemen, my name is Tomáš Mandličák and I come from Slovakia, from Technical University of Košice, Faculty of Civil Engineering. Together with my colleagues Peter Mesaroš, Anna Maria Behunova and Lucia Zemanova, we would like to present our research with title ICT Cost Impact Model in Construction Project Management. This presentation includes 4 parts. First of all, I will talk about problem statement or research problem supported by other researchers. Next, it's a methodology. That means, first of all, the aim of research. Next is data collection. I will talk about research sample and I apologize. And the last one, it's data processing. Next, I will present results of research, and last one, I give some findings and conclusion of research. Project management, or generally manage a construction project, means effective integration and coordination of resources to achieve a specified goal. According to Kerzner, project management is a set of activities based on primarily on planning, managing, organizing, and controlling enterprises or organizational resources with short-term goals that have been intended to achieve a specific objective and intentions. Construction project is closely related to investment activity, according to Všetečka and Belan. In the event of a construction project as an investment processes, the investment process of construction project can be divided into the following phases. That means it's first of all pre-investment phase, next investment phase, and last one phase of use and evolution. Another view of the construction project phase is described by Všetečka. First of all, it's pre-design stage, next it's design stage, and last one construction stage. Depending on individual phases, the construction project cost can also memorize and at the selected period of time. According to Petrakova, the construction project costs include all the expenditure of the investors or contracting authority of the construction project, which are related to project preparation by implementing and submitting a project to use. The success of CP depends on multiple factors: the intensity and the size of the effect of individual factors for the success of construction projects is different. For a detailed analysis of these success factors, the identification and specification of factors and the rate and intensity of their impact is essential. Based on these risk studies, research questions arises as to how information and communication technologies affect the costs of arranging construction projects. It's also necessary to define which information technologies have the greatest impact. The solution to this problem is to find an answer that will be very important for practice. These researches takes into account the situation in the construction industry and is based on the experience of existing project managers. The environment of foreign companies operating in Slovakia raises the premise of the general use of new research findings. This new knowledge can form the basis for important decisions in the implementation and information and communication technologies in the management of construction projects. The assumption that some technologies have a positive effect on reducing costs is the basic of research. If this area or idea is not confirmed by research data, it's not possible to build an economic mathematical model. The main aim of this research is to analyze the impact of information and communication technologies on the costs of construction projects. This process is demanding as the management of CPs. Therefore, in the final part, the ambition is to find an economic or mathematical model of the impact of ICT on the cost of construction projects. This goal stems from through analysis of already implemented work as well as general knowledge from practice. This research is carried out in the conditions of Slovak construction industry and takes these facts into account here. Data collection. The questionnaire was the main tool for data collection. The questionnaire focused on the use of ICTs and their impact on the prospects of construction projects. The questionnaire contained several parts. The first part contained basic characteristics, issues, that means the construction size, the participant in the CP, legal form, activity, and so on. The next part was focused on specific information and communication technologies, their use, submission. Part of questions focus on the impact of these technologies on costs of construction projects. These data are the basis for the analysis and creation of an economic mathematical model, the so-called cost impact model. And the questionnaire was distributed in Slovakia. Respondents, there are from construction companies, that means from participant of construction projects point of view, there are contractors, subcontractors, designer and developers, and investors. As a method, above construction companies in Slovakia participated in the research. The participants in the construction projects answered examined questions. The structure of the research sample is shown in the table or in the figures and in the graphic representation. It reflects the representation of construction companies by size and also the percentage of participants in a construction projects. That means left side and the right side. Data processing was performed using several statistical methods. In the first place, it was the processing and description of descriptive statistics, where the primary data were identified. Subsequently, contingency tables were compiled and the data were also divided into the monitored groups. Following these conclusions, several other statistical methods come up which provide a means of summarizing research results. As the aim of research was to analyze the impact of selected ICTs and design mathematical economic model, the EHP method was used as it is a mathematical expert method. It seemed to be the most suitable means of fulfilling the research goal. The project managers and theirs answered the questions where they determined the level in the following statement. This method truly compared these values, so-called each with each. The basis of this was the creation of a matrix and subsequent interpretation into a graphical form where a summary number was generated representing the impact of the technology. And the AHP method has also been used in the decision-making process in several studies in the construction industry. There were researches to identify key factors in the success of construction projects, the identification and the degree of risk, and the success of implementing various materials and technologies or their impact. on the importance of criteria such as economic, environmental, functional, aesthetic, and health aspects. The EHP method has also been used to identify and quantify risks and other factors, which is important in this research. The quantities are the relative significance of the criteria are arranged in a square matrix of related significance. That means there are some pattern EHP method and steps to achieve a final goal. This model has identified the areas with the greatest scope for cost savings, which may be better for directing attention and aiming to save costs. This research identified key information and communication technologies affecting supply chain costs. The individual evolution of the importance of individual categories through expert evolution is unique. The benefit is considering the benefits and specifics of the industry by experts who operate in this market, especially in construction market. The above also present the basic benefits of research for practice and the construction industry. This model is of recommendatory nature based on statistical probability of impact. The values given by the final information technology impact model represent the coefficient of the probability of the impact on cost reduction or cost saving. However, before the impact of these technologies is evaluated and the final model is proposed, it's necessary to describe from the research the real state of use in information and communication technology. First of all, the use of this technology is essential, and so it's possible to examine these impacts. The degree of digitalization in construction is generally insufficient. The potential offered by current technology is huge. Utilization can be the first step to achieving cost saving in the management of construction project. The level of use of ICT varies in the individual phases of a construction project. Information technology in large companies is used at the level of 3.43 in the pre-design stage. On the contrary, in a medium and small enterprises, it's only at the level of 2.01, which is significantly less. You can see in the picture. In design stage, the situation with the use of information technology is the best. The large companies reach the level 4.04, which is a high utilization or exploitation rate. Medium and small companies reach the level of 2.17, which is also more than in the pre-design stage. Large companies also reached level of 3.89 in a construction stage. Small businesses had a value of around second, and the overall average reached 2.92. On this basis, it can be stated that information technologies are used in construction, but their potential is still sufficient for this network to expand. The situation is similar when using communication technologies. In the pre-design stage, large companies achieved the use of these technologies at the level of 3.28. For example, for small businesses or enterprises, it was 1.75. That means significantly less. In the design stage, these results were the best. This means that the large enterprises have reached a utilization rate or exploitation rate of 3.87, and medium and small enterprises have reached a level of 2.01. That means you can see in the picture. The construction stage was also a relative phase for large companies where communication technology were used to a large extent, especially for large companies. These values were 3.81 for large companies and 1.77 for medium and small companies. On the next figure, you can see all impact model. That means for every stage, first of all, it's a pre-design stage, design stage, construction stage, but another slides will be described every part or every stage and these results in every stage. The information and communication technology impact model's main goal are to reduce the construction project's cost through information and communication technology. As can be seen from the values, the greatest sense of using information and communication technologies in the pre-design stage. In this stage, this model points to the highest coefficient, which represents the greatest impact on cost reduction. This confirms the research hypothesis that information technologies use positively affects reducing costs in individual stages of construction project. Based on the HAP method, the model was the first design that carries a wealth of information regarding the impact on cost reduction in the management of construction project. This model indicates the degree of impact of technology in a particular phase of the project. Communication technologies have a greater impact in the pre-design phase. In the design stage, they have a significant share in reducing costs, the so-called document management systems. Their strength was also confirmed in the construction phase. The impact of information technology on cost savings is greatest in the pre-design stage. In terms of specific technologies, the best are cloud systems, as well as the use of smartphones and other communications applications, which will effectively help reduce costs in the process of managing construction process. For example, another BIM technologies as well as controlling tools are also effective, which has a direct impact on reducing costs, and price resource planning systems make a significant contribution to achieving cost goal. In other words, they also reduce the cost by using them. Their specific measure is defined in the proposed model. These results are among the main findings of this research. The proposed model points out the possibilities of how to effectively contribute to reducing costs by implementing and using individual groups of technologies in construction project management. Research aimed at analyzing the current state of use of information and communication technologies and identifying, quantifying the impact on cost reduction has with several interesting, in some cases, possibly expected findings. The rate of use of information and communication technologies in construction has space for growth. The current situation is not bad, but there is a real space for improvement. The implementation of new technologies can achieve improvements at every stage of construction project. The best results in the exploitation of information and communication technologies are in the design stage. This applies to both groups of technology, that means construction, in communication and information technology. Thank you very much for your attention. If you have some any questions, don't hesitate us. There are some email contacts. Thank you again.
Good afternoon. My name is Jana Smetankova, and I am from Faculty of Civil Engineering in Košice, concretely from Center of Research and Innovation in Construction. I would like to present our article with the title, Impact of the COVID-19 Pandemic on the Educational Process, Use of Innovative Educational Technology. Article and presentation is divided into 4 parts, concretely. Introduction, innovative technologies and the educational process, methodology, and last part is results and conclusion. The COVID-19 pandemic is a global health crisis. Due to the pandemic situation, it was necessary to introduce the different message to protect against COVID-19. For example, increase of hygienic standards, increase hygienic, wearing face mask and respirators, regular cleaning, and disinfection of common areas and preventing the movement of people. Individual education institutes had to move from full-time education to distance learning. As many as 91% of students were affected by the temporary closure of schools. There are several measures that prevent the spread of COVID-19 in school, for example, testing, quarantine, and monitoring of students and staff, vaccination of students and staff, ensuring physical distance, increase hygienic standards, the need to wear face masks or respirators, detailed discussion of the measures in the place, and screening and care for sick students, teachers, and other staff, and other measures. Next part is focused innovative technology in the educational process. It was the pandemic that accelerated the implementation of selected innovative tools in the educational process. Increasingly, M-learning and e-learning tools began to be used. M-learning is learning processes via the internet or network using personal mobile devices, for example, smartphones, tablets, and laptops. M-learning uses mobile learning tools, for example, videos, animations, tutorials, games, quizzes, interactive assessment, discussion forums and chats, and information and communication tools. The use of M-learning has many advantages, for example, mobility. Students can study at any place, and at any time. mLearning provides instant access to relevant contents. Next advantages is support of independence. Students learn at their own pace. There is no pressure on students to understand a particular concept or lesson within a particular lessons. Next advantages is support of dynamics. mLearning allows teachers to insert a variety of images, presentations, audio files, and videos, allowing them to adapt their interpretation style to a wide range of students. Next advantages is better completion rates and higher retentions. Online courses are most concise, and the structure of the information provided is more dynamic and transparent. Last advantages is support of the teamwork. mLearning contains three parts, concretely. First part is learning management system. Learning management system represents the function of student management and courses, students' evaluations, monitoring, and their activities. Next part is learning content management system. Learning content management system includes function for creating contents, courses, the import, export, and sharing. Last part is information and communication technology. Information and communication technology are communication tools to support synchronization and asynchronization of teacher and students. Next part is focused on methodology. The research was focused on the issue of teaching evaluation and the Faculty of Civil Engineering of the Technical University of Košice before and during the COVID-19 pandemic. The main aim of the paper was to compare the student approach to study and evaluate individual study subjects. The research sample was conducted by Eai and by the MICE information systems. The return rate of the questionnaire in the second year was relatively low. The data were obtained through an online questionnaire. As part of the research, students of the Faculty of Civil Engineering Turkey were addressed. In the period before the pandemic, 668 students were contacted. In the period during the pandemic, 724 students were contacted. Of the total number of students, the return was at the level of approximately 14% and approximately 12%. The questionnaire consists of 9 questions and was divided into 4 sections concretely. First section is information about the respondents, concretely study program, year, form of study. Second section is approach to study, concretely subjective evaluations, mainly students' opinion. Next section is evaluation of subject, concretely definition of a significant subject, mainly positive or negative experience. Last section is evaluation of distance teaching, concretely form of teaching, content of teaching, and students' approach to study during individual waves of the pandemic. The first part of the research, data on respondents were obtained. The research was carried out in 2 periods. First period is the winter semester of the year 2019, and next period is in the winter semester of the year 2020. Therefore, the number of respondents differs. The return of questionnaire recorded a significant decrease feedback from students. Percentages increase in return was recording in the study program, concretely of bachelor study program, civil engineering and architecture, engineering and traffic structures, technology and management in construction, and building with environmental purpose. And in engineering study, concretely study program, civil engineering, engineering and traffic structures, technology and management in construction, and building with environmental purpose. Another part of the research was focused on the analysis of the students' approach to study. Students answered the simple question, how do you do evaluation or approach to study? Due to the fact of a change in the form of teaching, various innovative technologies, say m-learning tools, were implemented more quickly into the educational process, for example, Tuke Moodle and Cisco WebEx. They were provided to students through the Tuke Moodle system. Study materials, audio and video recordings materials, online tests, and online communications. Students also use the Cisco WebEx applications. Cisco WebEx information and communication tools is application for calling, messages, meeting, and working. The use of this platform increased the connection with students through video conferences, increased cooperation and interactive between students and teacher. The utilization rate of these tools increased by almost 70%. With the increase of digitization and the use of innovative technologies and platforms, satisfaction has increased and student access to study has improved. Part of the research was also focused on the evaluation of individual subject of study. In both cases, the most evaluation and analysis subjects were focused on the mathematical discipline. For example, Mathematics 1, Mathematics 2, Numerical Mathematics and Mathematical Statistics, and Descriptive Geometry. Of the professional subject focused on architecture, design, and structure were most analyzed in both periods, for example, building studio, building structures, typology, technical equipment of buildings, and technology of construction process. The last part of research was focused on the evaluation of distance education. Students defined preferences in the areas of real-time teaching according on the schedule, teaching by means of video or audio recording of the curriculum, submission of study materials, consultation by email, live consultation by WebEx, and telephone consultation. Students did not prefer telephone consultation at all, and the most preferred element of distance learning were teaching through video or audio recording of the curriculum, sending study materials, and live consultation through Cisco WebEx tools. Another part of the research was focused on the evaluation of distance education during the first and second wave of the COVID-19 pandemic. Students commented on the form of teaching and the contents of teaching. According to students, the form and context of teaching improved during the second wave of the pandemic compared to the first wave of the pandemic. The last part of the research analyzed students' approach to teaching during the COVID-19 pandemic, namely the comparison of the first wave of pandemic with the second wave of the pandemic. The obtained data confirmed the statement that with the increase in the use of digital technologies and the implementation of innovative elements, the level of student satisfaction increased. As a result of the pandemic, the implementation and use of selected innovative technologies and processes in the educational process has increased rapidly. Various information and communication tools and the learning management system were used to a great extent. Satisfaction rates increased significantly during the second wave of the pandemic. Teachers used more innovative tools and digital technologies, which increased the flexibility and attractiveness of the subject. Adaptation of contents to the listener, better presentations, use of digital tools such as virtual reality, building information modeling tools, and other innovative technologies and tools. Great restrictions have arisen, especially in the area of connection with practice. Many teachers provide lectures by experts from practice, but students lack direct interaction of construction sites, in construction companies, and laboratories. The aim of future research will be a true analysis of the impact of the COVID-19 pandemic on the educational process. The aim of future research will be to create crisis automata for education. On the basis of the obtained data, individual procedure steps, methods, and tools will be determined, which will directly help to increase the efficiency, productivity, and quality of education during the crisis periods. Thank you for your attention.
Dear ladies and gentlemen, my name is Josef Husar and I will present at the 6th Eai International Conference Management of Manufacturing season the article Optimization of the Production Process of Defect Identification in the Production of Face Shield using Fuse Deposition Modeling Technology. At the first, we need to say something about types of additive production. At present, there is a wide range of additive technologies. The differences are mainly in the way in which the individual layers of the model are applied, and the range of usable materials used for object creation. Choosing the most suitable additive production process for a particular application is very difficult. For your needs, the material extrusion method was chosen specifically FDM, Fuse Deposition Modeling. This technology uses direct application of the material by melting in the print heat, extruding it after it reaches required temperature, and afterwards it creates the desired model layer by layer. The most common materials are thermoplastic. FDM technology is also the most widespread form of 3D printing. At the same time, it is the least economically demanding 3D printing technology. The disadvantage of this technology are the long printing time and printing quality. At the first step is 3D printing is convert the CAD model to a G-code format required for the 3D printer. The program contains the coordinates according to which the nozzle moves, print and extrusion speed, and other operation parameters required for successful model creation. FDM printing is based on the principle of melting materials, that is the form of a plastic string, a filament. The filament is wound on a spool from which it is unwound required. The print heat when prints the physical 3D model layer by layer according to the digital model. The molten material is extruded through a nozzle onto a production platform where it cooled by active fans, and after the subsequent solidification, the final model is created. The parameters and cause and printing errors using FDM technology. The first is the printing surface, layer adhesion and layer thickness. The surface must be perfectly flat for the most accurate print possible. The adhesion of the layer depends on several factors such as the printing speed, the type of materials, the printing temperature and nozzle diameter of the height of the layer. Next parameter is layer thickness, which FDM printing it is possible to see different layer height, the layer height of 50 to 800 microns in use. Next parameter is nozzle diameter, variable from 0.2 mm to 3 mm based on the used filament diameter. The diameter of the nozzle directly affects the weight of the extrusion. While printing, it is necessary to monitor that the extruder dispenses from correct amount of filament. This process has significant meaning for dimension accuracy of created model and print quality. Next parameter is printing speed. Visually, a slower print speed supports a higher quality results, although the time saved of the higher speed may be authoritative for some manufacturers. It is safe to say that lower print speed are required for high quality production. Next parameter is nozzle temperature. Temperature affect the visual result and the mechanical properties of print. The types of materials used is important. Next parameter is infill pattern and infill percentage and number of outer perimeters to bottom layers. SARS-CoV-19 is severe acute respiratory syndrome coronavirus 2. It is the same given to the new coronavirus in 2019. COVID-19 is the name of a disease associated with the virus. SARS-CoV-2 is a new strain of coronavirus that has not been previously identified in humans. On the basis of the European Centre for Disease Prevention and Control has established basic preventive recommendation in the fight against COVID-19. Do not touch your face. The virus can enter your body and out your eyes, nose and your mouth. So it is important that you do not touch your face with unwashed hand. Wash your hand. Frequent washing of your hand with soap and water at the last 20 seconds is thorough cleaning of hand with alcohol-based solution, gels of tissues is recommended in all settings. Stay away from infected people. Avoid close contact with people infected with COVID-19. Avoid social gathering. Avoid physical gathering events and other social gathering in areas of ongoing community transmission and follow your local recommendation for mass gathering. Using the face mask. Wear the face mask indoors and outdoors whenever a physical distance from other people cannot be guaranteed. Methodology. Due to already mentioned 2 types of 3D printer were used for the printing of shaped shields, namely Creality Ender 3 Pro and Creality CR10 Max. These are SIM PLA FDM printers that are affordable. PETG Plastic Mladej filaments was used at the materials for the printing of shaped fields. It is a strong and tough material which is characterized by good temperature stability. This material is sustainable for printing large objects due to its small shrinkage during printing. Unlike other materials, PETG is more resistant to acid and solvents, high and low temperatures. It is possible to thermoform and object extruded from it or to polish and with heat. The material was chosen because of its properties and especially its relative flexibility and resistance to higher temperatures, face shield used by healthcare professionals and first contact people are often used for several hours. Therefore, they must be disinfected in or heat sterilized to prevent the transmission of virus. As mentioned in the introduction, our aim was to choose among the large number of 3D models of face shields that best meets the condition of rapid production. The design of face shields consists of protective frame, protective foil, reinforcement, 2 cret nuts and screws, 1 cover fold unit. As part of the preparation of the G-code, all the components necessary for the production of one face shield were placed on the printing pad. Thus, the optimization process was implemented for 3 components. During the process of printing face shields, we acknowledge a number of problems, specifically the adhesion of surface when was the shrinkness of materials and subsequent detachment. Also, for the first piece, the problem was a long printing time. We tried to remove this by changing the initial layers speed and the initial layers height, proper way of calling of there is absence also played on one of the key tasks in this chase. When we come to results, I will say something. It is well known that the design quality of commercially available FDM device is often debatable. Those device-specific settings often consist a unique modification that may not apply to every device. However, this article presents a software solution and error analysis during the optimization of these processes, which are characteristic of a specific case of efforts of rapidly production thin wallet components. If we want to evaluate the overall shortcomings that we announced during the printing of shape shields, it is necessary to choose the right method. The most sustainable method is the cause and effect diagram, also called the Ishikawa diagram. Diagram cause and effect was processed for FDM condition of shape fields printing. Figure shows us the individual errors we announcement during components printing. As for the printing of plastic nut covers for screws, their production was seamless, their composition is solid, so the chosen materials is ideal for their production. As can be seen from the figure, most of the shortcoming accuracy mainly of the frame of the face shield. The reason is mentioned in thin wallet design. At the end, I will say something about conclusion. In the first wave of the fight against COVID, our company for several months with a great shortage of protective equipment used not only to protect your country population, but also to protect workers in the medical, social and other spheres. Unknown, many manufacturing companies required their operation of the product focus of production of this protective equipment. It was difficult to initiate fast to ensure that the necessary materials was available to all. Therefore, many young people who had 3D printers took this task. The faculty teams also took parts of production over 1,000 face shields on the premises on the Faculty of Manufacturing Technology of Technical University of Košice established in Prešov. Since the operating stage of the first wave, latest 4 months, many improvements were made. Therefore, in this article, we have sought to analyze the shortcoming identified during the period using in a cause and effect diagram. Also, On the basis of the analyzed process of 3D printing and assembly, it was possible to shorten from the original 4 hours to final time something around 1 hour. As a result, the overall model before the after optimization changing minimally, but all user-centric requirements were maintained without changing the technical characteristic. As a main advantage of optimization, we consider that the total time has been reduced 4 times and all failures have been eliminated, and this fall allowed us to procedure longer numbers of the fail shot and help more people in the first line. Thank you for your attention.
Dear ladies and gentlemen, let me present our paper entitled Relationship Marketing, a modern marketing strategy as a tool to increase the competitiveness of the company in the market. My name is Anna Maria Behunova and I come from Slovakia, from the Technical University of Košice. The presentation consists of 4 parts: introduction, methodology, results, and conclusion. Nowadays, where supply is higher than demand, companies are fighting for every customer. Every company strives to gain a better position in the marketing compared to its competitors. In a spirit with higher levels of competition, it is not enough to offer the customer a cheaper product or service, but it is necessary to obtain in true quality services, benefits, and a reward for their loyalty. One of how a company can gain an advantages over the competition in the introduction of CRM, which in translations means customer relationship management. It is about the overall management of the company communication with customer and maintains a good relationship with them in the long run. With the help of CRM, the company has the opportunity to obtain more information about its customer, their complaints, suggest for improving service, but also about its activities, establish processes, and the effectiveness of new communication strategies. Marketing, often inflected not only in connection with business, is still largely and now to many people. We can deduce the meaning of this term from its very name. However, it is not just a matter of selling and buying as it is, but these activities include wholesale processes as well as other activities within the market, the aim of which are satisfied customer. Not only marketing, but especially branding plays an important role in sales. With the right marketing moves, the company can activate people to buy a product or service. However, the role of branding is to encourage customers to be loyal to a particular brand and therefore to the company itself. It is a process of selling and loyalty to brand in the long run. The aim of this paper is to describe CRM, customer relationship management, its important positions in the company efforts to increase its comparative position in the market, and the implementation proposed in the condition of a particular company. CRM is customer interactions. This interaction is provided by a total of 6 independent elements of CRM. The quality of each element is very important, as it affects the entire quality of CRM, and this element includes relationship management, email interactions, follow-up and projects, documents, email marketing, and sales calls. The implementation of CRM system in a company involves many activities that precede in implementations. The implementation of a CRM system must be included in the strategic planning of the company. The separate process of implementing a CRM system in a company consists of several parts. Each author divides these parts differently, but the sequence of activities and their content is always the same. Idea, basic concept, create strategy unites, strategy development, project planning, launch of sub-project, and control. The company in which the research was carried out will focus in business activities on provision of advertising and marketing services. The successful implemented CRM in a company implementation depends on 4 factors: processes, people, technology, and data. The main points for creating a CRM system in the company is creation of a new department in the sales department responsible for managing CRM in the company and evaluating sales plans. The owner of the company will directly influence these departments. Development of the CRM strategy. The new department of the sales department that we propose to create should set as the main goal the growth of the customer value and the growth of these tools in the company as the main goal. To make the work more efficiency, we recommended expanding the pen system used by the company with the possibility of archiving documents in electronic forms. Improving the registration of customers who are interested in cooperations. Expansion of the call center activities to address new and lost clients, and introduction, recording of their communications. Also, set up a record of communication between the sales representative and the clients. Planning the implementation of CRM system in the company is very important, and the cooperation of all departments and divisions is necessary to define the schedule, costs and resources needed for the implementation of the system. Technical departments. Technical department overview and determination of the number of costs to expand the company information system to be able to archive documents in electronic forms. Electronics ordering of company products. Marketing department. Marketing department specify the information that the department needs to follow to create new production and offer the customer. Comparing the number of costs incurred to obtain customer information from sales representative or obtain such information from external sources. Simplify business order that can be more easily presented to the customer. Shopping department. Shopping department analyze of sales processes for selling advertising to the customer and creating simple processes. Consulting new processes with the marketing department and sales representatives. Call center. Call center increase in occupancy. Verification on the possibility of extension by another operator. Training of call center employees to address new customers. The introduction of a CRM system in a company is currently an easily acquired tools that give the company an advantage over the competitions, of which there is a large number in today's market. The aim of this paper was to describe CRM, its important position in the company's efforts to increase its competition's positions in the market, and the implementation proposed in the condition of a particular company. The company in which the research was carried out has good preconditions for implementing a CRM system. The economic situation in the company has not been favorable in recent years, so the introduction of CRM as one of the solutions offers an opportunity to improve these unfavorable situations. It was found based on international company documents, the company records a decrease in customer and at the same time it's not able to reduce its cost linearly. With the help of the proposed change, the company has the opportunity to monitor and analyze in which processes and ways of communication with customer loss the necessary revenues, which activities are inefficient for the company. At the same time, it brings proposal change and more effectivity communication with customer, which can help communication acquire new as well as their former customer, which will lead a revenue increase in sales and increase the company's competitiveness in the market. Thank you for your attention.
Hello, my name is Yaroslav Hora. First of all, I would like to thank all of you for being a part of this conference. We are going to discuss possible methods of valuing startup, agenda, introduction, research and finding, methodology, result and discussion, conclusion. Introduction. With the startup concept we can meet today very often, their definitions and views of startup are more. According to European Private Equity and Venture Capital Association, startup is a company that is in the process of starting a business or shortly after starting a business but is not yet achieving sales. The very first stage of a company's life cycle can be considered a business idea. At this stage, the founders have not yet taken any steps to implement it. Later, when they start developing a product or analyzing the market, we move to the so-called niche phase. Startups are all the more important for economic growth because they create new jobs and introduce the latest technology. One of the most popular startup valuation methods used by angel investors points out that it is first necessary to determine the average valuation of startups in a given market area. Then, according to Forbes, it is possible to determine how startups compare to others in the same region by evaluating the following factors: management team strength, founding team, the vary dramatically depend on the background and experience of the founding team, opportunity size, market size. You need to be interested in a pilot product. The larger the potential market, the better, especially if there are potential customers who are already to buy. Product technology and competitive environment, competition, entering a market uh, entering a market full of competition is a risk, and as a result the price will fall. In the case of a startup entering the open market space without competition, it can get a much higher investment. Marketing, sales channels, partnerships, growth, and engagement. Ideally, it is necessary to prove that the user base is growing and that people are engaged. Need for additional investment, and others, like many methods, evaluating the factors is a very subjective process. Methodology, risk and uncertainty in business. In business, some risk is necessary. To be successful, entrepreneurs need to learn to accept risks that cannot be avoided and to mitigate risks that can be managed. The best guarantee against risk is a good core team, business-friendly government, diversified marketing channels, and prudent financial management as well. Business success here not only in a on a market economy, but the goal of each individual or business entity is to satisfy their needs and maximize the benefits of each of their inputs. One way to define a company's performance is the company's ability to achieve the desired business results in the form of inputs that are consistent with the company's goals expressed in measurable unit. Measuring business performance, however, striving for the highest possible profit is also associated with higher risk and financial instability. Such a traditional approach to measuring performance, and it is used in financial decision making in the company, has been replaced in recent years by additional so-called modern approaches to performance measurement, which take into account several factors: result and discussion. Many things need to be taken into account, from the management team and market trends to product demand and related marketing risk. Startup valuation methods are particularly important as they are usually applied to startups that are currently in the pre-income stage. It is necessary to get acquainted with the popular methods of valuing startups, based on which it is possible to better understand how to evaluate a startup company without returns, and at the same time it will be possible to negotiate, for example, a better agreement with investors, for example, so before achieving returns. Methods, PERCOS method. This method represents a simple estimate of the value of the startup, and part of it is used in technological startups. The method evaluates five critical aspects of startups, like concept, prototype, quality management, mergers, startup plan. Second method, scorecard valuation method. This is one of the most popular business valuation methods used by angel investors. It works when comparing a startup with other that already works, for example, and in which has already been invested. Venture capital methods. With this method, it is necessary to know the ratio of the share price to its returns in the sector in which the startup operates. The current value of the startup can be calculated as the final value, return on investment, the value of the investment. This method is very useful in examining the risk that need to be managed in order for a startup to be successful. Method of market valuation of human capital. Valuing a startup before starting operation is not an easy task for the investor, because most of them don't know the value of intangible assets. Project can be awarded in two ways: get to know the team and their expertise, evaluation of the people how develop the project, or perform purely mathematically valuation based on the size of the market. The potential investor should calculate the value of the ideas, know-how, and human potential of the team. Asset-based valuation methods. The simple valuation of a startup without income is an asset-based valuation. For this method, it is necessary to quantify the initial cost of the startup, the total value of tangible assets, any outstanding debt. Discussion. Key factors to consider during valuation before starting a business, before achieving revenue. There is a link between these three concepts. Number of users, it is necessary to prove to exist customer, the more the better. Marketing effectiveness, growth ratio, and here is a link between these three concepts. As strong marketing strategy will lead to impressive growth. It is never possible to assume that the valuation is permanent. The startup will cost only as much as investors are willing to invest. Also, it is never possible to assume that evaluation is direct. There is almost nothing direct in business. Conclusion: as a result of this pandemic, the global economy as well as the economies of individual countries will enter a recession. As mentioned in this article, supporting startups is very important because startups create new jobs, bring new innovation technologies, and thus contribute to economic growth. And many factors need to be taken into account, from the management team, the situation and trends in the markets, as well to the demand for the product itself, and of course the marketing risk. After evaluating all this, it is necessary to take into account that it is still only an estimate and the reality may be different. Thank you for your attention.
Hello from the Eai team. We have a great new feature in the Eai Compass that you can use. Upvote your favorite presentations to show appreciation and respect to the best presenters. Open up the Eai Compass, go to the program, find the presentation you want to upvote, and hit the thumbs up button. It's that simple.
Ladies and gentlemen, dear participants, thank you so much for your attention. After the internal meeting of organizing committee and reviewers suggestion, I will introduce you the best paper. The best paper is from the research team of Mr. Lopez Flores from Ecuador, with the title Monitoring of Industrial Process Based on Industry. Congratulations! And I will invite you to participate on our next 7th International Conference on Management of Manufacturing Systems, held in beautiful spa town Krynica in Poland. Please save the date from 5th to 7th October 2022. To learn more, visit our website. The aim of the 7th International Conference on Management of Manufacturing Systems is to create a bridge between the science and practice. We will bring together worldwide people from academic and industry and exchange ideas to cooperation in the era of innovation and high technology. Thank you so much for your attention, and don't hesitate to contact me via my email if needed.